for Cisco SD-WAN, in fact, they call it secure SD-WAN. So I will discuss a couple of things prior to we get started with the actual training, right? So you can see the agenda of this training would be to cover a couple of modules, right? So those modules would be like an architecture of the SD-WAN, the Cisco SD-WAN, right? So mainly we are going to focus on, we are going to cover only Cisco SD-WAN because there are many other vendors as well. When it comes to the SD-WAN, there is Versa, there is Silver Peak, there is Juniper, there is FortiGate, and of course Palo Alto. Cloud Chinix, is now part of Palo Alto. So obviously we have got so many other vendors, right? But obviously this training is only for the Cisco SD-WAN. We are going to cover the architecture of the Cisco SD-WAN because see, as of today, there is no open source kind of technology when it comes to the Cisco SD-WAN. Each vendor have their own individual thing. So they have different components and then they have different protocols. Some of them are using BGP to exchange the routes in between the remote sites, but mostly like all of the vendors are using their own proprietary protocol to exchange routes in overlay. But yeah, let's talk about the agenda when it comes to the Cisco SD-WAN. So in Cisco SD-WAN, the first, yes, Yogesh L, you raised your hand. Do you have any questions here?
There was some Bluetooth issue. I got it disconnected now.
Okay, great. So guys, you do not need to be raise your hands who are joining online, right? So you guys can just unmute yourself and ask your questions. So especially this statement is for the online participants. Whenever you got a question, go ahead and unmute yourself. You do not need to seek for any kind of permission before asking questions or before unmuting yourself. In fact, I would suggest, in case if you do not have any background noise at your end and you are using headphones, then you can sit unmuted yourself. So when I talk about or when I say conversation, which means that we should have questions and of course the answers, right? See, if I am the only who is speaking, then obviously you would feel little bored. So better that you try to make this conversation more interactive as much as possible by asking the questions. Okay, so that's why I said like you can even sit unmuted, right? I'm talking about the online people, right? So you can sit unmuted, but just make sure that you do not have any background noises. That's all. Okay, so let's talk about the agenda. Cisco Secure SD-WAN, because it is a secure SD-WAN. We call it secure SD-WAN. There is a reason behind that. Because not only Cisco is providing SD-WAN services, but also at same time on the same box, it can also provide security features or security services. So they call it secure SD-WAN. Okay, so let's talk about the architecture. This is the module 1 that you will be covering. So in this module 1, basically, you are going to learn about the architecture of the Cisco SD-WAN, in which you would learn that how many different components you have here and what are their uses. Like for example, here you can see orchestration plane, which is also known as vBond, right? So you need to understand that okay, what is the role of orchestration plane or what is the role of vBond? Because when I say orchestrator or vBond, it's the same thing in Cisco SD-WAN. So vBond itself is known as orchestrator. And then we have got management plane, which is also known as vManage. So you need to understand that what is vManage, right? Similarly, it goes with control plane, which is also known as vSmart. So in control plane, mainly there are two major components. One is vSmart, which is a device, and then there is a protocol called OMP, right? So it is really critical for us to have vSmart and OMP configured properly for exchanging control plane information between the device. So in architecture, you are going to cover all the different components which are participating in Cisco SD-WAN. So I just said that orchestration plane, which is also known as orchestrator or vBond in Cisco SD-WAN. Then we have got vManage, we have got vSmart, OMP. So these all are the different components which takes place in Cisco SD-WAN. And of course, in data plane, you have got vEdges, not only vEdges but also cEdges. And nowadays you are going to have only cEdges, not vEdges anymore, right? Because Cisco, obviously you can purchase them from Cisco. Cisco is still selling those devices, the Viptela devices, but Cisco pushes more towards CAGs. Like if you are going, meeting someone from Cisco that, hey, we have got a requirement for SD-WAN, right? So they will come and pitch you CAGs only when it comes to the managed routers, right? But then you can tell them that no, we don't need CAGs, we need only VAGs. So obviously Cisco can also provide those boxes. So those boxes are still in service, and Cisco just still have that option. That's about the data plane. So not only you are going to have VHs, but also CHs. This V, this V keyword, you see that V correct in the beginning of each character name, each device name. So in the beginning of each device name, like V bond, it's starting with V and V manage. So this V indicates Viptela. So basically, the Cisco SD-WAN was Viptela SD-WAN earlier, and later then Viptela became part of Cisco, right? I mean, obviously Cisco acquired this Viptela solution, right? So now all that Viptela technology is part of Cisco since they acquired. I believe Cisco acquired this Viptela late in 2017, somewhere around 2017 and 18. Since then, this Viptela SD-WAN has been part of Cisco only. We started training in 2019 when it comes to the Cisco SD-WAN, right? So basically, this SD-WAN training was started by us late in 2019. So as I was talking about this V, right? So V indicates Viptela, right? So don't get confused with that V. So under data plane, then you have got many terminologies such as TLOGs and then IPsec and then VRoute and VFD. So we're gonna discuss about these terminologies during this architecture, during module 1. Then obviously we will be discussing, or we will have a discussion around the managed platform types like VAGs, CAGs and their capabilities, because we have got like so many different types of platforms which are supporting SD-WAN technology nowadays when it comes to Cisco. Like earlier we had very limited number of platforms. Like if you talk about 2020s or 2021, right? So we had only ISR series and ASR series supporting SD-WAN technology. And nowadays, almost you can say that every router, every platform is supporting SD-WAN technology when it comes to the Cisco. It's just that you have to load a correct operating system which is supporting SD-WAN. But nowadays, even, your industrial routers or, within ISR, then they have also launched one light version of CAGs like 1100 series, 1000 series. I mean, there are many platforms which are now supporting SD-WAN technology. Earlier, we had very, limited scope. Like, as I said, we had ISR 4K and ASR 1K supporting Cisco SD-WAN technology. Okay, then we have got Cisco SD-WAN Cloud on Ramp. This is the one topic that ideally I cover in the end. Why? Because if I am deploying the, let's say, software as service, right? Basically, they are saying that we just have to describe it. We don't have to implement anything. But at least I perform the implementation for SaaS. Like I perform the lab for cloud on ramp for SaaS, right? Software as service. So if we wants to perform the lab for cloud on ramp for SaaS or cloud on ramp SaaS, right? Software as service, then we need to understand the technology first. Then only we can perform this lab. So I would be performing this lab, like I'll be deploying cloud on ramp services for SaaS, software as service. But I'll be explaining you that what is the role of cloud on ramp services for infrastructure as service, but we cannot really perform it. I can display these steps that, okay, this is how you are going to take these steps to implement your cloud on ramp services for infrastructure as service. And these are the advantages, right? So that I can discuss with you, but here we cannot really perform the lab in real environment. Why? Because infrastructure as service is all about the cloud, right? Whereas we are having our Cisco SD-WAN lab as on-prem. Since we have on-prem labs and we do not have like, vbond configured with a public IP address, so it will not be possible for us to implement this thing, cloud on ramp for infrastructure as service. But yes, I'll be giving you complete. So then we have got
Okay.
the another module, right, which is module 2, where we are going to learn about the controller deployment. So in controller deployment, basically we are going to learn that how can we deploy like vmanage, how can we deploy vbond and then vsmarts, right? So like all these control components. So we will be learning that how can we deploy them, right? That's one thing. Second, when it comes to the controller deployment, basically we have got like two different methods to deploy the controllers. One, we can deploy them in cloud. The second, we can deploy them on-prem. Here in Cisco content, we have only on-prem deployment, but obviously we can, like I can describe you that how you can deploy them in the cloud. But when it comes to the lab, so in a lab, we are going to perform only on-prem deployment. So the lab that you would have access to will also allow you to perform only on-prem deployment. And then we have got like, obviously, when it comes to the controllers, all of them are virtual devices or software based devices, right? Like you cannot ask Cisco to give you a hardware vmanage. That's not available. It's not available. I mean, you cannot even force Cisco to give you the vmanage as a hardware. What they can do, they can say, okay, we will give you the hardware, and instead of giving a hardware based vmanage, they will give you, or they will sell you a ucs server, and on top of that they will install the vmanage, and then they will say, okay, this is the hardware vmanage, right? This is what they can do. But after all, like vmanage or all these control components are software based devices, except vbond. Vbond can be an exception. Why? Because when we talk about the vbond, right, as I was talking about this orchestration plane, so this vbond is not a different device. Actually, it is a vantage router. It is a vantage router. And now vantage router can be either virtual or physical. Therefore, vbond can also be a virtual and physical. So obviously we do not really recommend anyone using vbond as a hardware device. We always recommend them to use the virtual devices, because there is a reason behind that. Vbond will never, like your orchestrator will never participate in the data plane. So since your device is not going to participate in data plane, then why would you waste your money on the hardware device? So it's better to use a virtual device when it comes to the vbond, right? So that's why I would say that all these control components are going to be virtual device, and to install them you would require some sort of hypervisor, isn't? If you are deploying a virtual device, let's say you are doing on-prem deployment, right? So you would require some sort of hypervisor such as kvm or maybe esxi. So on top of vmware esxi, you can deploy all these control components, or maybe if you are using kvm as a hypervisor, you can also get them deployed. Does that make sense? Okay, so that's how you are going to work with that. Also, we will talk about the scalability and redundancy, right? And then after all, you would require to have a certificate authority server, CA server, which is mandatory. Either you should have a public CA or a private CA. It's all your wish, but you must have a certificate authority server within your environment. Okay. So obviously you must have a CA server configured, and obviously you should download a device list from your smart account. And this device list will have a list of all those vantage routers which you have purchased from Cisco to deploy in your environment, right? So this device list will contain, or it will consist the chassis number and serial number of all those vantage routers that you have purchased from Cisco. So that can be downloaded from your smart account, or maybe, if your vmanage, which is your management plane, right? I told you that vmanage is your management plane. So you can have internet connectivity available on your vmanage, and then you can provide your smart account credentials directly onto vmanage, and then vmanage can go to smart account directly and can download the device list dynamically. That is also possible, but also you can download this device list manually from your smart account, and then you can get it uploaded to your vmanage. But this certificate thing is very important, is very critical, because certificates were never easy task, never ever. I believe that all of you are working professionals, and since all of you are working professionals, so I'm assuming that at some point of time you must have met you must have met with the certificates or certificate authority. Obviously, to manage those CA servers, I mean, you would have a different team. Ideally, nowadays there is a different department managing these CA servers. Being an engineer, wherever you require a certificate, for example, if you are doing the SSL decryption on your F5 load balancer, right? Or maybe any load balancer, right? So you would require that SSL certificate. Even if you are doing SSL decryption on your firewall, next gen firewalls, right? You would require that certificate. So, and even for accessing your devices, for example, you have got a, let's say firewall, right? So by default, your firewall uses self-sign certificate. And obviously in most organizations using self-sign certificate is it comes under non-compliance. So to make it compliant, what you have to do is you have to install a CA signed certificate on those devices as well. So I am pretty much sure that you must have done this before. So in similar way, basically in Cisco SD-WAN, each component must have its identity certificate, and each router must be installing that root cert chain which you have got from your CA server. Okay, so each device must be configured with the root cert chain as well as with an identity certificate. So obviously, all of these components which are going to participate in Cisco SD-WAN, such as your vManage, vBond, vSmart, or even managed routers, all these devices comes with some default root cert chains as well. Some default root cert chain, which I believe which consists root cert chain from DigiCert, from Symantec, from Cisco, and a couple of more. So if you are using them as a CA server, then you don't really have to install the root cert chains. Then you just have to focus only on identity certificate. But if you are using a private CA, if you are using an internal CA, because internal CA is a private CA, so you cannot expect that root cert chain will be pre-installed on all your components, right? You cannot expect that. So obviously in that condition, you will have to install root cert chain manually on all components. Not only root cert chain, but also obviously you would have to generate CSR certificate signing request, and then you would have to obtain the identity certificate, and then you will have to install that identity certificate on each component. So obviously each component must have a root cert chain installed, and of course the identity certificate. Then only all these devices can authenticate each other, or they can participate in your SD-WAN fabric, or I would say in your SD-WAN topology, right? Then obviously you're gonna talk about the control plane connectivity. You need to know that what could be reasons behind if your control connections are not coming up between the controllers, right? So you need to know that how to troubleshoot them. So that's what we are going to cover during this section 2, or I would say under controller deployment, right? And then we have got this section 3, right, which is all about the router deployment, where you would learn that how to deploy your managed routers. And obviously we will talk about the zero touch provisioning, PNP, right? So that's about describe. But when it comes to the configuration, right, so we are going to onboard only virtual routers. So in our lab we have got only virtual routers, not the physical routers. Whereas that's why they have pointed out this thing like describe managed deployment, right? So I am going to describe that how does this zero touch provisioning works, or how does this plug and play work, right? Because for VEDGs we call it GTP, zero touch provisioning, and for CEDGs we call it PNP, plug and play. So we're going to talk about that, or we will have a discussion around GTP and PNP, and of course that how can we onboard a managed router. So obviously we are going to learn the onboarding of the routers, but using virtual routers only, right? So that's what we will be performing in our lab. And then obviously you would learn that how do we perform data center deployments and regional hub deployments. Okay, and of course you have so many things there under data plane, like circuit termination, TLOC extension, dynamic tunnels, underlay, overlay, connectivity. So you need to understand that what is underlay, what is overlay. Obviously, since your overlay is always going to be dependent over the underlay, because if underlay goes down, obviously overlay will not work. So that is something that you need to understand. Under section 3, you have got like OMP, TLOCs, and so many other things as well. Like you need to understand that how to get VRRP implemented, OSPF implemented, BGP implemented, EIGRP implemented, because these traditional routing protocols, or this traditional protocol which is called VRRP, it comes under FHRP, first hop redundancy protocol. So these all protocols are supported by the Cisco SD-WAN managed routers. Ideally, if you look at maybe Silver Peak or maybe some other vendor specific SD-WAN, they have got some limitations to support all these traditional routing protocols. They have some limitations, but in Cisco SD-WAN there are no such limitations. Okay, in any branch or anywhere, wherever you want, you can deploy all these traditional protocols. Okay, so that's all about the routing and other stuff. But then you have got the policies. Now remember that the template is also part of this section 3. So you would learn that how to create configuration templates. So configuration templates are nothing but it is a way to make the configuration on your managed routers or any other component. Like for example, I mean, it's a GUI based deployment or GUI based configuration, GUI, graphical user interface based configuration. So if you want to configure your managed router using UI user interface, then use templates, configuration templates, like feature templates, because you can also create the CLI based templates. But remember that Cisco recommends to use the feature templates or feature configuration templates, which is completely UI based templates. But also you could create the CLI based template. But the ultimate goal of creating templates is to make the configuration onto your devices. I hope that if somebody has already worked over Palo Alto, Palo Alto Panorama, so in Panorama, you get those options to create the templates, the device templates, and then you attach those devices to, those specific templates to push the configuration onto devices. So similarly, obviously, we have got the different way of attaching the devices to the device template and a different way to create those templates here in Cisco SD-WAN. But at the end of the day, the concept is quite similar. Then we have got the policies. So under policies, you're going to learn so many things. And in fact, I would say this is the most critical part of this Cisco SD-WAN. You're not going to modify your policies every day in production environment, but obviously when you are trying to set up a Cisco SD-WAN for any customer, at that point of time, the policies will be so critical for you, because policies are responsible to define the topology, like how traffic is going to move from one branch to another branch, or whether you are going to allow it or not. Either you're going to have hub and spoke kind of connectivity, or partial mesh of connectivity. So all those things will be defined by the policies. So that this is what you have here, like control policies, which you can utilize to perform route filtering, or maybe to modify your topology. And then you have got the data plane policies where you can perform like traffic steering. So you can steer your traffic based on your requirement. For example, you have got a requirement of service insertion where you wanted to insert your firewall service. So you can perform all those things here, right? Even it supports like application aware routing, like for certain applications, you wanted to select a specific path, or you wanted to prefer a specific circuit. So that's what this application aware routing would perform for you. Then VPN segmentation, obviously there is a concept of end-to-end segmentation using VRFs, or you call it VPNs. So in Cisco SD-WAN, basically these two keywords or these two terminologies are same actually. When I talk about VPN or VRF, it's the same thing. Point is that on all control components, like on vManage, when you are creating a template, you are always going to create it by name of VPN. But when your vManage creates a CLI configuration for your managed router for the C edges, then it uses a VRF keyword. So VRFs have already, it has always been there, right, in Cisco. It's not something new. So basically VPN and VRF is same thing. It is used for the segmentation purposes. Obviously we were using VRF in past for the purpose of segmentation. Still we are using this VRF for the purpose of segmentation. Then application aware routing, DIA, there is a concept of DIA as well. If you are doing backhauling, let's say you did everything backhauled, like whenever a branch user is trying to access an internet, so all your traffic is backhauled into data center, and then you are trying to access an internet. But nowadays there are so many SaaS based applications which are famous, such as Office 365, Salesforce, right? And then you have got Dropbox, then you have got Box, right? And many other. We have got so many different SaaS based applications. So obviously if you are trying to access those SaaS based applications, then the performance for accessing those applications would not be really up to the mark if you are trying to access those applications via DC. Like you are backhauled into DC, and then from DC you are going to internet, and then you are trying to access those services like Office 365, MS Teams, and so forth, right? So the performances of these applications would not be up to the mark. So to improve that performance, sometimes we have to implement DIA for certain services or certain applications, which is also known as direct internet access. It's just that at branch level, you should have a internet connectivity. If you have got a internet connection at branch level, then you can also implement DIA. direct internet access. So like, for example, you could define a policy that for Office 365, you are going over to internet directly. You're not backhauling into data center. Okay. So that's called the DIA, direct internet access. So obviously it is pretty much cool feature. Then you have got security policies, and that's why we call it secure SD-WAN, because it supports the security policies. Since it supports, which all security policies it supports, as I told you, application aware firewall. You can also call it next gen firewall because it is also going to support IPS URL filtering. And these all are on box security features. I'm not talking about leveraging the cloud based services. You can also leverage them. Like you can leverage all these services using Cisco Umbrella or maybe Zscaler. So you can direct all your internet traffic through the Cisco Umbrella or maybe Zscaler cloud based security solution, right? But I'm not talking about them. I'm talking about the on-box security features. So these all security features like application aware enterprise firewall or IPS feature or URL filtering, these all features are on-box features. So since these all features are on-box features, so you can call it secure SD-WAN because these are the most important things. In most cases, you are going to use only these security features, nothing more than that, because you have got application aware firewall, you have got IPS, you have got URL filtering, you have got AMP, which is advanced malware protection. And then you have got SSL and TLS proxy. That's all you would like to deploy in production environment if you wish. However, at same time, I would make one more statement that ideally it is not recommended to use like IPS URL filtering, AMP or SSL decryption on your routers. It is not recommended. You can enable, Cisco supports that, but it is not recommended. Yes, firewall feature, you can definitely use that, utilize that, use it. It is perfectly fine. But do not use like IPS URL filtering. Why? First of all, if you are enabling any one of those features like IPS URL filtering, AMP, SSL proxy, any one of them, two of them, three of them, or all of them, doesn't matter. You would require one additional software to be installed on your router. And to install that additional software or additional Linux image, you would require additional CPU cores and memory. I mean, that's why it is really critical for you to understand the customer requirements. If customer is asking you to enable any one of them, like forget about application aware firewall because that does not require any additional hardware resources. So you can enable or disable anytime. I mean, that feature is totally different. That does not require any additional software or additional hardware. But when you talk about IPS URL filtering, AMP, SSL, TLS proxy, like any one of those features, all of them, two of them, three of them, doesn't matter. If you are even enabling single feature out of these four features, you would require that software, additional software to be installed, which is a Linux based image. And to install that, you would require some additional CPU resources, CPU cores and memory. If you did not purchase a router with a correct configuration, and now you are trying to install that software, that would get failed because that software would not be able to reserve the CPU cores, the required CPU cores and required memory. So if there are no enough CPU cores and memory available on your router, you cannot even install that image. So it is very important for us to sit with the customer and to explain all these things to customer and to ask whether they want these features to be enabled or not. If they want to enable these features, like at least one of them, let's say I saw one customer who who asked us to enable IPS feature, right? So for enabling just IPS feature, obviously we increased the number of CPU cores on that router, so the cost of the router went higher. That's that. Not only that, but also you could integrate your managed routers with cloud security. You could integrate your managed router with cloud security, such as Zscaler, or that is also known as SIG, Secure Internet Gateway. So Zscaler is a cloud-based SIG provider, cloud-based SIG provider, and same goes with Cisco Umbrella. So you could leverage either Cisco Umbrella or Zscaler, and there are many other as well, right? Like Palo Alto Prisma. But Cisco has really made it easier for you to perform integration with Cisco Umbrella or Zscaler because they have a predefined template to fill in. Like if you are integrating your managed router with Cisco Umbrella, there is a predefined template that you just have to fill in and you're done. Similarly, it goes with Cisco Umbrella. But if you are, let's say you are trying to integrate with Palo Alto Prisma, which is again a cloud-based SIG provider. So if you are integrating your managed router with Palo Alto Prisma, then you have to make all the configuration manually. But yes, that integration is also possible, like with Cloudflare or so. Then obviously we have got DNS security. DNS security can be implemented if you have a subscription to Cisco Umbrella. Remember that this DNS security can be implemented only when you have subscription to Cisco Umbrella, because Cisco Umbrella provides this DNS security feature. So you can integrate all of your managed routers, or you can integrate your SD-WAN with Cisco Umbrella when it comes to implement your DNS security policy. So DNS security is also known as first level of security, like Cisco calls it first level of security, because your DNS resolution will be filtered based on your policies. Like you can define that, okay, if these all URL categories are blocked, these all URL categories are allowed. So when you are generating a DNS request, obviously it is mandatory, right? If you're trying, like if any end user is trying to access any domain, first they have to generate a DNS request so that they can obtain an IP address. So that DNS request will be inspected by the VNS router and will be forwarded over to Cisco Umbrella. Now Cisco Umbrella will check the policy against that DNS request. If that DNS request is containing the domain which is already blocked by you, so in response, it will provide an IP address of the block page. So that user will be displayed a block page that you are not allowed to access this. So basically, you blocked the access of the end user. I'm sorry. At very first level, at the time of DNS resolution only. Even your machine, your user machine never tried to establish a connection with the actual application server. This is why Cisco calls it first level of security. So that can be done, right? Then we have got quality of service. So you can also deploy the QoS policies, right? So basically it supports scheduling. You can perform scheduling. You can create multiple queues, which means you can perform queuing. Then within queue, you can have like schedulers configured like LLQ or WRR, right? Weighted round robin or low latency queue, because those are the scheduler which were supported earlier by the Cisco routers. Now remember, this quality of service is not that flexible as much we had earlier on traditional Cisco routers. Like on traditional Cisco routers, we have got so many things. We have got like LLQ, we have got CBWFQ, right? Class-based weighted fair queue. I'm not sure that if you are already aware with those terminologies. If not, then you would not be able to understand it. But point is that earlier, like on traditional Cisco routers, right? We had a lot of flexibility when we configured this QoS service, right? Or QoS policy. But in Cisco SD-WAN, like in SD-WAN, you do not have that much flexibility, but yes, at least you have got some couple of features which you could leverage here. But quality of service is nothing, but it is just a way to provide some sort of preferences, for some specific data, right? Like even the policing and shaping is also supported. So ideally, being a CE router, customer edge router, it is recommended to enable the shaping. And then policer can be applied. For example, I know that whenever, in my organization, whenever employees are free, they are watching videos over YouTube, or maybe they are going through the Facebook and they are watching videos. So I can perform policer, or I can implement a policer for Facebook and YouTube that, okay, at any cost, right? I would not let my employees to access YouTube at higher rate than 5 Mbps. So I can reserve a bandwidth of 5 Mbps for the YouTube. And if somebody tries to access, if somebody is trying to breach that contract, then I would simply drop their data. That's what policer does, right? So if you are implementing policer, whenever there is a breach of contract, right? Whenever there is a breach of policy, then policer will drop the data. Shaper slows down the traffic. It does not drop immediately. Rather, it would like to put your traffic into queue and it will slow down the data transmission. Shaper is very important, especially in that case where, for example, your WAN connection is a fiber optic connection, right? probably it is a 1 Gbps transmission, right? I mean that it can support, like the transmission media is supporting your 1 Gbps, right? I mean there is a 1 gig port where you have terminated your fiber optic cable. It's a WAN connection, right? It's a Ethernet connection, but you purchased only 100 Mbps. You are paying 100 Mbps, like you are paying to your service provider based on your contract, and you had a contract with service provider for 100 Mbps only. But transmission media, but the media is supporting what? At rate of 1 Gbps. So what service provider does, they apply a polisher at their end. And from the customer end, customer router will always try to send data at that rate which it supports, which its transmission media supports, right? So let's say you had an interface of 1 Gbps. So your customer as a router would always try to send data at rate of 1 Gbps. However, it will be discarded by the WAN edge router. So in that condition, you need to ensure, being a customer, that my router, my WAN facing router, WAN edge router, is not transmitting data at higher rate than 100 Mbps. Why? Because we had a contract with service provider only for 100 Mbps. So for that purpose, there is a technology called Shaper that we could utilize. So Shaper will slow down the traffic at the end of customer edge. So if provider is using polisher, then being a customer, it is our duty to enable the Shaper. Why? Because obviously if you had a circuit of 1 Gbps, if you had a circuit of, I mean, obviously transmission media is supporting 1 Gbps, but you purchased bandwidth of 100 Mbps. In that condition, you should apply the Shaper at the end of customer or on the WAN facing router, right? So that's why you have got that feature as well over here, right? Shaper. And then finally, there is a section 6, which is management and operations.
Saurabh,
Yes, Naeem,
Saurabh,
tell me.
one question regarding the QoS.
Mhm.
So you have mentioned all these scheduling and queuing and shaping and all those things. So what is that which is missing? You said it's not like
Okay,
full
let me tell you.
QoS.
So queuing, right? So in CBWF queue, we had up to 64 queues, right? Traditionally, here maximum 8 queues can be created. Okay.
Okay.
That's just one example. So that way you would have so many limitations with this quality of service. Okay. All these terminologies are there, but with limitations. You get my point. Similarly, like you have got all these security features, but those are with limitations. It's not like when I talk about the URL filtering, then you are going, you are going to get all those features which are provided by the Palo Alto firewall or maybe Cisco FTD. No, obviously no. Why? Because it is just a router, right? And there is a small software that you will be installing on top of that. So
these are hardware limitations, right? And these are not really the SD-WAN limits.
I would say these are the software limitations, not hardware.
Okay. So if I upgrade the hardware, still I will have only 8 queues.
Yes.
Is that what you mean?
Yes.
Okay. All right. Great. Thanks.
So management and operations, right? So obviously you need to know that how we can really manage things from the vManage, how, like our operations team, like for example, from an organization point of view, they will have always two separate teams. One is kind of like, I would call it engineering team, right? And second one is like kind of operations team, right? So ops team. So how ops team can use this vManage to monitor the network, right? So that's what you would see. I mean, I will explain you that how you can generate some reports from the vManage, how can you get reports, how you can perform monitoring, right? And how authentication takes place, right? And obviously vManage also supports the REST API, right? I will talk about that a little, right? I'm not going to perform any kind of automation here. That's not part of this training. But point is that it supports lots of REST API calls. So I'll give you, or I will explain you that, okay, these all are the API calls which you can make, right? For example, if you wanted to get the device list, right? So what is the API call that you could leverage, right? Or maybe you wanted to attach a device to a specific template, or maybe you wanted to detach a device from a specific template, right? So there are some API calls for all these tasks, right? So I would give you a complete list of the API calls which are currently supported by the vManage so that you can even test by your own. But again, you would have to create those applications using Python, or maybe you have to, you have to use some sort of, I would say, some other languages where you could make a API call, right? That's what you would require. But I'm not going to perform all those things. What I will explain you that, okay, these all are the API calls that you can make to your vManage. These all are the API calls which are supported. And then obviously the software image management, like how to upgrade all these components. So that device upgradation is also part of this training, right? So you would learn that how we can upgrade the SD-WAN devices, such as vManage, vBond, vSmart, and Managed Router. Obviously, there is a way of upgrading the devices, right? So that we must follow. Like, for example, in Palo Alto, if you can take any example, even Cisco FTDs or maybe FortiGate firewalls. If you are using their management system, like kind of a FortiManager, and in Palo Alto, if you're using Panorama, right? In FTD, obviously you have to use FMC, because without that, it will not be possible to manage your FTD unless you are using the FDM. So that's a separate story altogether. But like for all these firewalls, you have got a centralized management kind of thing, right? If you are using them, then when you perform a upgradation, like it is always instructed that, for example, for FTDs, like the OS version of the FTD firewall must always be either equal to FMC or lower than to the FMC, either equal to controller or lower than to the controller, right? So in similar way, in similar fashion, you are going to have certain rules here in Cisco SD-WAN, and there is a sequence in which you should perform upgradation, right? So that's what I'll be explaining to you, so that in case if there is a requirement for upgrading your maybe control components or maybe your managed routers, so you should be knowing that, okay, what are the key parameters. Okay. So these all are the total, like in total we had 6 sections, right? So you are going to cover all these topics. Now, there are some labs that you would be performing. So I'm giving you the labs to cover, right? I mean, there's a list of labs that we are going to perform, like interconnecting SD-WAN component, installing root CA, right? And then vManage, GUI mod, vBond via CLI, installing vBond in vManage, right? So these all are the labs. So in total, if you look at here, right, in total, we have got around 51 labs that we are going to perform during our course, right? Finally, this is the lab topology. And this is a fixed topology. You cannot modify that. Like if you want, okay, no, I want to have 2 ISPs or 2 MPLSs. No, that's not possible. It's a fixed topology. And whatever you want to perform it using this topology, right? So you would have access to this topology only, where you have got like one internet service provider, the other one is the MPLS provider. Then we have got some remote sites like remote site 1, remote site 2, and remote site 3. Then in left side, you have got your DC data center, right? So you can see that, okay? So we have got like all these components here. So understanding this topology is very important for us. I mean to say for all of you who have joined this. So if you look at this DC data center, within this data center, like this is your DC. So in this data center, we have our control components like vManage, vSmart, and the vBond. Not only that, but also we have got a CH router. So you would have like understanding that how to deploy a CH router. And then all other devices are the VH routers. Like here you can see these all are VHs. This is also VH, and these all are also VHs. Sooner we will update this topology, we would increase like CHs here. Like for example, most importantly, we are going to have, the site 2 VH replaced with the CH. But again, the things will remain same, right? Whether I'm using CH or VH, it's just that CHs will use a different operating system, and the templates, the supported templates are also different for the CHs. Like for example, if I take an, if you remember security policies, right? So we had concept of uh, application aware firewall, right? We had a concept of IPS, and then we had a concept of URL filtering. Although security policies are not supported by the V-edges. So on V-edges, you cannot deploy them. So that's a limitation. And that's why, Cisco comes to customer and says, hey, why are you pushing us, or why are you focusing on V-edges? Why don't you go for C-edges? Even you can implement all these features if you want, right? So that's how Cisco is trying to manipulate customer, and they are trying to focus more on C-edges, not the V-edges. Okay, so you have got this DC in left side where we have this DC C edge. Using this C edge, we can deploy all those security policies, right? So you would understand that how to create device templates for the C edges, but also you would learn that how to deploy security features onto C edge, right? And apart from that, then you have got V edges at site 1, site 2, and site 3. Site 3 is designed to support TLOC extension. So there is a technical feature called TLOC extension, which is very important from a transport redundancy point of view, right? From a transport side redundancy point of view, there is a feature called TLOC extension. So this site 3 is mainly designed for that purpose only, for TLOC extension only, right? So you would perform that lab using site 3, right? So basically you have got 3 remote sites and 1 data center. Now you can either have full mesh connectivity. When it comes to the data plane connectivity, you can have a full mesh connectivity. And in fact, the default behavior of the Cisco SD-WAN is to provide you full mesh connectivity. So all the remote sites and data center, they all can talk to each other. They all can send data to each other directly. They all will establish an IPsec tunnel automatically, right? Okay, that's the default behavior of the Cisco SD-WAN, but again, you can always go back and modify this default behavior, right? You can change it to maybe hub and spoke or partial mesh, whatever, dual hub and spoke topology kind of thing, right? So it totally depends upon the requirement, right? Then apart from that, I mean, obviously you must have understood that, okay, we have got 2 transports here. One is internet, the other one is MPLS. And when I talk about the internet, that's a real internet. In this topology, you would get a real internet. So for example, if you wanted to implement DIA, so you can test that out and you would see that it will go to internet directly. So it has a real internet connection here. That's another advantage of having this topology. And then apart from this, like this is obviously this is the topology. And when you are accessing this topology, this lab, make sure that you are not turning on all the devices at the same time. Don't do that ever. If you do so, forget about having access to the lab, because these all components are really CPU intensive components, especially when it comes to vManage. vManage is the most intensive device, most CPU intensive, memory intensive, storage intensive. It takes most amount of time even to start. Yes, like other devices can start like within a couple of minutes, but then vManage takes at least 15 minutes. Okay, so what we recommend, or what I recommend to all of you, that if you have a plan to perform some labs, power on, like right click on vManage, power on it, and then stay calm for next 5-10 minutes, 10 minutes at least, and then check if application services have got started on vManage. If application services were started, then power on any other device. And also you should power on only those devices which you are going to utilize in your lab. If you see that, okay, there are some, I mean, let's say you are just working in DC, then why are you turning on all these components? You get my point. So if you are working only inside data center, then you should enable, or you should power on only those devices which are part of this data center. Correct. Obviously, there will be some cases where you will have to power on all these devices. Let's say you are working on all sites and including data center. So obviously you have to power on all the devices. I agree to that. I'm okay with that. But what I'm saying is that if you are working within data center only, then you should not power on all other devices, or other site devices like site 1 devices or site 2 devices or so. Questions? No? Okay, cool. Then next thing is that the solution. Okay, they are talking about the solution overview. We can talk about this later. First of all, I would have some basic questions to all of you. Now it's all of it's your turn to engage or to engage yourself actively, right? With my questions, I would have some, I would have some questions, and then you will have to answer them or you will have to explain them. What is SDN? Exactly, networking, software defined networking.
Network.
And I believe that everybody must have heard about this in past. I mean, it's not something new, right? It has been there from a long time in the market, right? When it comes to the SDN, software defined networking, what is it? What is the meaning of this software defined networking?
So as in SD-WAN, we actually separate the control plane from the
No,
data plane.
I mean that's okay, Naeem. Let's put it apart. Like, not, let's not talk about a
If
technology
instead of
specific
doing
thing.
manually, we are working through software defined.
Exactly. Like, basically, I would say it is a controller based networking. It is a controller based networking. Like, you would have a centralized controller from where you are going to perform networking. Correct. Like, mostly we do things manually. Like, earlier we were doing things manually. For example, I'll give you a couple of examples. In data centers, you were configuring each and every device, each and every switch manually, like whether it was an access switch or maybe catalyst giant switches, 4500, 6500, those switches. We always configured them manually. Whatever we were doing it manually, right? um when it comes to the catalyst switches, again we were doing everything manually. Or maybe it was about the routers, we were doing everything manually, right? Maybe we have got like maybe 1000 branches and two data centers, the DC and then DRDC. Let's say for a customer we had two data centers, DC and DRDC, and then we had 1000 branches. Correct. So ideally, like, if I really talk about the traditional networking, so let's say we had DC and then we had DRDC. So first these DCs were interconnected, and then ideally, like, to interconnect our remote offices or to connect our remote offices with these data centers, we were relying over MPLS in most cases, or maybe we were using internet, right? So obviously both DCs were connected with the internet and of course with MPLS. And then let's say you had a branch one. In branch one, you had MPLS connection in most cases, but sometimes you were also having internet. I'm talking about the traditional networking, right? Then you had branch two, right? You had MPLS connection as well as internet. So over MPLS, since it was a private connection, that was a primary connection for you in most cases. And then over the internet, you were relying over the DMVPN. In Cisco, we had a concept called dynamic VPN. So over the internet, to make a secure connectivity between branch and your data center, right? We were relying over the DMVPN. That's what we used to have, right? In some cases, like in most cases, DMVPN was not there. I will not say some cases. In most cases, DMVPN was not there. Instead, we had two MPLS connections. In branches, we had two internet connections from two different MPLS providers. Like, what I can do, I can also make it MPLS, right? Like MPLS provider 2, this is provider 1 and this is provider 2. Then in DC, we had internet connection, a separate internet connection, right? From DC and DRDC both. And then we had MPLS connection only in branches, in remote branches. So if someone wanted to have an access to that application which is hosted in data center, they were going to data center using the MPLS connection. If one MPLS goes down, the other one was there. If both MPLSs are down, then everything is down. Okay, I mean, for the branch, right? Now, even if they were trying to access an internet, everything again was backhauled into DC. And then from DC, they will go to internet, come back to DC, and then from DC come back to branches. That way we had most of the networks configured. This is the layout of the traditional networking, right? Like most of the customers, most of the banking customers, or maybe non-banking customers were using this kind of connectivity where they had like their own data centers. But let's say you had a customer who does not have any data center, then obviously you would have just internet connectivity everywhere, and maybe in each branch they are using their local storage or maybe local file servers, and they will access everything locally, right? And in case if they want to have the internet access, then you would provide them kind of broadband connectivity. But like where you have got a centralized stuff, then you would have to rely on this kind of connectivity, either use DMVPN or IPsec tunnel, like point-to-point tunnels. So if you have a less number of sites, then probably you can rely on the IPsec tunnels, right? But in most cases, you had like kind of MPLS connectivity. This is the traditional networking, right? Now, you let me know, like within data centers, you had so many devices. You had storage servers, right? You had then your Nexus switches, or maybe those Catalyst high-end switches like 4500, 6500. You had WAN edge routers where you were terminating these MPLS connections or maybe internet connections, right? You were running BGP as a protocol, so you were doing all that configuration manually, isn't? Would you all agree with that statement or not? Okay. Same goes with branch offices, right? So this is totally a traditional networking. So before SDN, we were doing everything manually. Now, what were the issues? Can anyone explain me the issues with this type of networking that we had earlier? What kind of issues we faced actually? Forget about SDN for now. Obviously, it is increasing manual. Yes, it is increasing overhead. I totally agree to that. But what is the problem with that? Yeah, it's a time taking process. That's one thing, right? I'll give you some real time or realistic examples. Okay. DevOps, I'm not talking about the SecOps or NetOps. I'm talking about the DevOps. So what is the DevOps actually? Yes. So basically this automation first came into server side or software development side, right? I mean, in development, first automation came in, right? So when DevOps was introduced, right? So what was happening, like in case if someone needed to deploy an application, approvals obviously will take its necessary time, whatever it was taking before. But apart from that, like when it comes to the application deployment, so deployment time was reduced to some couple of minutes from couple of days, like from 30 days to couple of minutes or maybe couple of hours, right? I mean, that's how DevOps made things really easier for the developers or for the application hosting team. So DevOps was already introduced. So now if you are deploying an application, then making changes on the server side became so easy, and they were doing it so quickly. But when it comes to the network side was still same as before. So if you needed to make some changes, again, it will go through the change process, and it will take obviously longer time, and then you would be doing your changes manually. If let's say your change needed to be done on maybe 100 devices, so I don't think that you would make that changes in a single shift or in a single take. You would submit that change into multiple parts and for multiple days, right? And then you would be making those changes. It is a time consuming process, but also we had so many other challenges as well, such as, I don't know if someone of you felt in this situation. I mean, if someone felt this situation in the production, or maybe you fall into this scenario where mistakenly you either shut down the WAN facing interface for the branch router, or maybe you modified the ACL which was applied on the WAN facing interface, and that blocked the access. I don't know whether you observed this kind of scenario, or you had this situation. right? But like most of the network engineers, like who are having like somewhere around 12 to 15 years of experience, they must have seen this, that by modifying an ACL on the WAN facing interface, or maybe by obviously by shutting down this interface, which is a WAN facing interface, right? Obviously there are some scripting as well, like we had before, EEM scripting type of thing, where if interface went down, then it would come up automatically after a couple of after some time, right? I mean, we had those solutions, but let's say those solutions were not applied in your branch, and your interface went down suddenly. I mean, you shut down it mistakenly. So how would you recover that? I mean, it's a time taking process once again, right? You would search for some field engineer. Field engineer will give a widget, and then will give you the console access, or maybe you would ask that a field engineer to get the console access and then to bring up that interface, right? But it will take
That's right.
seriously
Yeah.
long time. That's one thing. Second, let's say you have got 1000 branches, right? You have got your primary connection was Tata MPLS, but now you have got, let's say, Airtel MPLS as well, right? So management decided that let's phase out, or let's not make Tata as primary MPLS. Let's make this Airtel as a primary connection. So you will have to make certain changes across all your 1000 branches. Just think about it, that how much time it will take. Maybe you are running BGP, right, as a protocol. Obviously, you would see in this scenario, in such scenarios, BGP as configured as a routing protocol, right? In most cases. So just think about it. If you have applied the BGP policies in all branches, you will have to modify that now across all branches on each and every router individually, right? And if you have got like 1000 branches, just imagine what would happen. Not only that, it's a challenge, right? And not only that, but also let's say your SNMP string was compromised. Now you need to update your SNMP string, and you have got like across your branches and DC, let's say you have got 10,000 devices or maybe 5,000 devices. Just imagine that how much time it will take to update that SNMP string. Let's say you modified your DNS server IP, or you modified your NTP server IP. These are very small things. But if you change it, then just imagine that how much time it will take for you to populate all those changes across your network, right? We had really, major difficulties, right? Obviously, we had issues with traditional networking, right? Then people started thinking that, okay, if we can do this like using some sort of automation or so, that would be easier for us. Like for example, if we are taking the backup of the devices manually and we needed to make the changes on, let's say, 20 devices, right? First I'll take the backup of all those 20 devices, and if I'm taking that backup manually, just imagine that how much time it will take. Right? Or even if I'm doing the software upgrade individually on all of the devices, right? Just imagine that how much time it will take. So we really had challenges, and that's how things got started to change, right? Like people started that no, there should be some sort of automation. There should be involvement of a software which can perform tasks on behalf of the engineers. That's how the controller based networking started evolving, right? So that's how these things started to evolve in the production environment, right? I mean, obviously we faced lots of challenges, right? So that's how the SDN came into the picture. First we faced the issues, right? And then to overcome to overcome all those issues, those difficulties, we had a concept, or then people started thinking about this SDN. So whatever you are doing manually, if some software can perform it on your behalf, that is called SDN, or controller based networking, right? It's a software defined networking.
Then what
Now
would be the future, sir?
I am sorry,
Without human intervention, will automation will take place without human intervention in future?
I am I didn't get the question, sorry. Can you please come again?
In future, will automation take over like without human intervention?
I will not really make any comment on that, right? I mean, I can't really see the future as of now because um, it might be possible, right? It might be possible, but I'm pretty much sure that even your automation is not going to work without manual intervention. So I know your question is valid from your standpoint, but I mean, lot of people are thinking that maybe automation will kill their jobs, especially into networking industry, since automation is is spreading quickly now, right? But I still think that it's not going to happen because even to run automation, we need the engineer, right? And not only that engineer who is familiar with that automation tool, not only that, but also that engineer should be familiar with the networking as well, because ultimately the core technologies are still same. The IP networking, IP connectivity is same as before, right? The routing is still same as before. There are some new things that have came up, but still the core technologies are same. So I would not really, I mean, I don't see that automation is going to replace the human beings. No, I mean,
Okay, sir. Thank you.
you would still require, like all the organization would still require. And on top of that, let me tell you, how many organizations we have that can really adopt the real automation. I mean, obviously it comes with some expense, right? It's not like you can deploy or you can have the automation in place without some cost, right? There is a recurring cost with that, right? So people will look at each and every aspect and then only will take the decision whether they want to automate everything in their network or not, right? Obviously, I can think of Amazon or maybe the Google or Microsoft in their clouds. Obviously, they are going to use the automation. They are already using it. But does that mean that they are not using network engineers? They are still hiring, right? They're still hiring. They have everything automated, almost everything automated. They're still making things more and more, in an automated way, right? They are working on it, but still they are hiring, right? So obviously, like automation is not going to replace the human beings. So that's that. Okay, let's come back here. So I was talking about the SDN. So first I took couple of examples here, right? And now even the requirement has got changed. Not only that, the requirement has also got changed now. Earlier, obviously, we had our applications, like private applications were hosted in our data centers. So if my branch users needed to have access to that private applications, they were coming to DC and having access to that application. If they needed to access internet, then again, they were coming to DC and having access to the internet. Now things have got changed. Why? Because you see that SaaS based things, right? You have got infrastructure as service, like cloud has evolved a lot, isn't the cloud has evolved a lot. Now you're not only implementing, you are not only deploying your private applications in your data centers, but also you are deploying your private applications in cloud, isn't? Things have got changed. If you are still using backhauling for accessing Office 365, just imagine that what would be the performance, isn't? So to improve that performance, we needed something different, right? We needed that, okay, for this application, traffic should go to internet directly if we have got the internet connection at branches. Like internet is moving towards the branch now. Earlier, we were not having internet connections at all at the branch level, but now we have that. So you need to make sure that you are providing secure internet connectivity to the branch. And also you need to make sure that for certain applications, you are going directly over the internet, especially for the SaaS based applications. So even the requirements have got changed, isn't? Like your audio traffic, your video traffic, then you have got SaaS based applications, right? So even you needed some changes, like maybe, routing with application awareness. So traditional routers are not enough capable to support application aware routing. Things are changing quickly, right? So not only we had issues with the existing infra, but also the user requirements is changing. So to meet those requirements, like for example, nowadays you have pretty much heavy applications. Earlier, if let's say if you take an example of a financial institution, right? They had their network. So earlier we were not having pretty much like heavy applications. So if you were having like maybe 2 Mbps of MPLS connection or MPLS bandwidth at the branch level, 2 Mbps or 1 Mbps was sufficient. But nowadays applications are rich, right? And they are heavy applications. So 2 Mbps is not going to work for those applications. So you need
It's all bandwidth consuming
exactly
program.
bandwidth consuming, right? So if your applications are more bandwidth consuming applications, you have to upgrade your bandwidth, the MPLS bandwidth. And if you upgrade your MPLS bandwidth, obviously the cost will get increased, right? So problems are there. I mean, were there. So then SDN came into the picture. So when we talk about the SDN, it is all about the controller based networking. It's just that you can perform certain tasks using software. For example, if I needed to change the SNMP string, what if I go to controller, I put my, like I replace my string and then it pushes that change to all devices across the network automatically. So the task that you did in couple of days, maybe in a week or in 10 days, that can be done within an hour or maybe within couple of minutes, right? Similarly, if you wanted to change your NTP server IP address or maybe DNS server IP address, right? So that can be done by the controller like within couple of minutes instead of doing it manually in 10 days or 5 days or 7 days, right? Even if you have thousand of devices. So that type of advantage you can get by having the controllers. And now even controllers have got the capability to perform troubleshooting and to display you that, okay, these are the options that you should try, or this is where we have the problem. You go there and fix it. That type of capability your controllers have got, right? Because artificial intelligence ML is everywhere now, AI ML, right? Machine learning and artificial intelligence. Okay. Now, when we talk about the SDN, right? Especially this SDN, okay? In Cisco, SDN is divided into 3 parts. Under SDN, we have got this SDA, software defined access, right? Or you can call it lane automation. So this is one of the technology that they have. Then we have got SD-WAN, and also we have got ACI, the Cisco ACI, right? So if you talk about the Cisco ACI, this is for Nexus devices, which means that this is for data centers, right? Because mostly you use Nexus in your data centers. Nexus devices are used in data centers only. So ACI is meant for the data center. Correct? That's one thing. Then we have got the SD-WAN, and this is what we are going to cover, right? This is exactly what we are going to cover. So SD-WAN is mainly used to maintain your WAN edge routers. What? WAN facing routers. Now remember, SD-WAN technology is meant to manage your WAN edge or WAN facing routers, not the lane devices. Now, if you want to perform lane automation, like if you are trying to manage your catalyst switches or your core routers, internal routers, which are not supporting SD-WAN, then you need SDA for that. And basically you do that using DNAC. There is a device called DNAC. There is a controller called DNAC. So you do lane automation using that device. So basically there are 3 categories that Cisco has divided your SDN. I mean, Cisco has divided SDN into 3 categories. SDA, also known as lane automation, SD-WAN, which will help you to automate your WAN edge routers or WAN connectivity, WAN connection. And then ACI is meant for data center. So if you are using, let's say, Cisco devices all across your network in lane, in when it comes to the WAN facing routers or maybe in data centers, everywhere you are using Cisco. So you do not only need to learn SD-WAN. That's one thing. That's one part of the SDN. If you really want to learn the complete controller based networking in Cisco, which is supported by Cisco, then you have to learn SDA. You also have to learn the Cisco ACI for the data centers. But ideally, a single engineer does not work on all technologies in most cases. Somewhere you can see that, okay, maybe you are all in one, right? You're working as a all in one, then you might have to work on all these 3 technologies. But in most cases, one engineer would be responsible to work only on one technology. Like if you are managing lane automation, then you would work only on lane automation, which means SDXs, which means that you will be working on DNAC. Cisco DNAC, right? And then you have got the SD-WAN. So if somebody is working on SD-WAN technology, then in most cases that person would work over SD-WAN technology only. Then you have got ACI. If somebody is working in data center, then that person should work in data center only. But most importantly, within Cisco, we have 3 solutions under SDN, software defined networking, right? SD-WAN is one of them. That's what I wanted to make you understand, that SD-WAN is not the end of the story, right? So we are going to learn only this SD-WAN part. Like this is one of the technology under SDN provided by Cisco. Does that make sense to all of you? In similar way, Juniper is competing with Cisco. Don't worry, because Juniper also have devices used in local area network as well as in data centers, right? So they also have got like kind of lane automation. They also have got the SD-WAN kind of thing, and also they have the automation for the data centers. So they are competing with Cisco. But apart from that, like if you really take an example of Silver Peak, right, which is now part of HP, right? So they are providing only SD-WAN services. They are not providing any kind of lane automation or kind of automation in data center. No, they are not. But yes, if you take an example from VMware, yes, they have a technology, or they have SDN technology for data center as well as for SD-WAN, but not for lane, local area network, right? Because Velo Cloud, right, is from VMware, right? Velo Cloud is one of the SD-WAN solution. Okay. Has anybody got any questions so far from online people?
No, sir. So is it preferable for Cisco only Cisco based SD-WAN, or do we need to learn like Silo and other SD
See,
as well?
the answer would be to get started with SD-WAN technology, Cisco is best among all. To get started with SD-WAN technology, Cisco is best. If you understand the Cisco SD-WAN, then I don't think that it would really take a lot of efforts for you to understand or to learn the other SD-WAN technology. As I mentioned in the beginning, Cisco gives you more flexible, robust, and it gives you, obviously it is most flexible SD-WAN solution among all of them. You can take any example. The kind of flexibility this solution has, the other SD-WAN provider don't have. Like kind of options that Cisco SD-WAN gives you, other SD-WAN providers don't provide that much flexibility. That's why I said, like, if you have learned, like, let's say you learned Cisco SD-WAN, then it becomes easier for you to understand the other vendor specific SD-WAN technology. But yes, to answer your question, see, it depends, like where are you working, right? If you are working for MSP, managed service providers, right, such as Tata. Now if Tata is selling Cisco SD-WAN, I'm sure they are also selling the Versa. If they are selling Versa, maybe they can also sell maybe Silver Peak to their customer, right? Obviously customer is king. If customer is saying that I have to use Cisco SD-WAN, then as a MSP you have to sell Cisco SD-WAN. If customer is asking for Silver Peak, then you have to, like, as a provider, as MSP, you have to sell Silver Peak. So it is all about the customer. So yes, it is good to get started with Cisco SD-WAN, but also it is a good idea to have some other vendor specific SD-WAN knowledge.
So this lab is centralized, right? So
Correct.
means there should be a VM instance, or how should we
Yes, you
work
would,
from that?
you all of you, right, who
Yeah,
are
yeah,
joining this meeting will have a dedicated access.
yeah.
So there will be a dedicated VM instance for each one of you, right? So that's how you are going to have access to your labs. So in case if you
Yep.
did something in your lab and you saved your configuration, next day you would find everything
Cool. Yeah.
as you
Done.
did. Yeah. So, okay. Now we are going to discuss further into Cisco SD-WAN itself. So yesterday we had a discussion around that why SD-WAN was needed. So we took a couple of real life examples from the production point of view, right? And then we found, yes, it was really it was really needed to have kind of controller based networking, right? Because we had so many different challenges, and I just gave a couple of examples. In that way you can think of so many other things as well, or so many other challenges as well, right? But that's how the evolution of the software defined networking got started, right? So in fact yesterday I said that even the user requirements have got changed completely, right? So you can see that the WAN has got changed. Like earlier, yesterday I drawn one topology, right, where we had like two MPLS providers, and then those MPLS connections were getting terminated in data center, and then from data center we had an access to the internet, and then each branch was also having like the MPLS connections, right? So that was the traditional way of doing networking, right? Or to provide connectivity to your branch offices, even to provide internet connection to your branch offices like this. So this is also kind of same topology, right? So you can see that you are having some users at your branch office, and then branch office is connected through the WAN to the data center, and mainly it was a MPLS type of connection, like it was a private connection, right? And then from data center you were accessing all your private applications, and in case if somebody needed internet access, then they were having access to the internet via data center only, since data center was only connected through the internet. So that was the traditional way, right? But now things have got changed. Why? Because users sitting at branch office need an internet access directly. Why? Because they are accessing SaaS based applications, right? So if you are providing the SaaS-based application access to the branch users via data center, then obviously the performance issues will come up or will be raised, right? So users will be raising some concerns around latency, or maybe, if they are making calls over the MS Teams, then they would obviously sometimes even the call will get disconnected, right? Or maybe there will be some lags in the video calls and so, right? So you would face so many different challenges if you are providing the access of the SaaS based applications to your end users or to your branch users via DC, like if you are doing backhauling, like if you are using the traditional way of networking. So now internet has moved to the branch level, right? So nowadays users not only accessing only private applications which are hosted in data center, but sometimes even your private applications will be hosted inside cloud, like public cloud, such as Azure, right? Or maybe AWS, or maybe GCP, right? So, or maybe Oracle, right? It could be any public cloud wherever you want to host your private applications, right? So it's not necessary that you would always have the on-prem data centers to host your private applications. Sometimes you would see that you are hosting your private applications in cloud as well, right? So you do not need to have access to only data centers, the on-prem data center, but also you need to have access to the multi-cloud. So when I say multi-cloud, which means we are talking about AWS, Microsoft Azure, or maybe GCP, and etc., right? So that's the meaning of multi-cloud. And at same time, as I said, that you would have access, like obviously end users would require having access to the SaaS based applications, right? So SaaS is nothing but software as service, such as Office 365, Dropbox, Box, right? Salesforce. So all these are an example of SaaS based applications. So obviously you need to provide access of SaaS based applications to your users sitting in branch offices, right? At same time, your users might require to have access to the internet directly, right? Direct internet. Maybe they are watching some, there is a team who needs access to the YouTube, right? So they need to play videos over to YouTube, through the YouTube, and then maybe they have to upload the videos over YouTube. To say in this branch, let's say your advertisement team, right? Digital advertisement team is sitting, so they need to perform something on YouTube. So if they are accessing YouTube via data center, obviously you're going to kill your MPLS bandwidth in most cases. right? I mean, in the earlier design, right? So for example, if the user sitting in this branch wanted to have access to the YouTube, right? So first they will be using this MPLS bandwidth, which is quite expensive for having access to the YouTube, right? They will be backhauled into data center, and then they would have access to the YouTube, right, via data center. So now things are getting changed. The user requirements are getting changed. You can see that, right? So earlier users were needed to, have access to the private applications hosted in data center only. But since the cloud has evolved, right? So you do not only have to access your on-prem data centers, but also you need to access your applications hosted in cloud or maybe SaaS-based applications, and maybe you need to provide internet access directly to your branch users. So things have got changed, right? And therefore, it is essential nowadays to have like kind of MPLS and internet, both types of connections at your branch. Like earlier, we had only MPLS connections, right? But now it is really important to have MPLS and internet both. Again, it depends upon the requirements, right? So sometimes you would be working for, let's say, for the security department, home security department, or maybe, kind of defense networks, right? So if you are working on defense networks, then obviously they will not allow you, or they will not have any internet connectivity at any branch, right? So obviously you just have to rely over the MPLS, right? So that's totally different scenario. Different approach would be followed for kind of defense network, right? So I mean, obviously, over there, you cannot say that, no, I must have the internet connectivity. You cannot make that statement. You have to utilize only private connections, right, for that purpose. But yes, apart from that, if you are having like kind of enterprise customers, then you can simply recommend them to save their MPLS bandwidth and to reduce the cost of, the running cost of the infrastructure, right? I mean, you can suggest them to have like internet in place of at least one MPLS provider, right? So let's say you can still have the MPLS connection, but also at same time, you would suggest them to have at least one internet connection terminated at all branch offices, right? And most important thing is that if you remember that in early days in the traditional networking, when we had the internet connectivity, then we were relying over the IPsec tunnels to establish the connectivity over the internet. I mean, either you were configuring the GRE tunnels, or you were implementing IPsec tunnels, and also you had one another option called DMVPN. So sometimes you were configuring DMVPN, since DMVPN supports like kind of multi-access network, right? I mean, it supports multi-access connectivity, right? But normal GRE tunnel or maybe IPsec tunnel would serve only point-to-point connectivity. So I mean, that depends like how you wanted to build your network, right? So but earlier, you needed to configure everything manually, such as if you were configuring DMVPN, you were doing all that configuration manually to allow communication between the remote sites over the internet, right? And similarly, if you were building up the GRE tunnel, again, you were doing the configuration manually, right, to allow communication between the remote sites over the internet, which means that whenever you were allowing your remote sites to talk to each other or to communicate with each other over the internet connection, then you needed some sort of overlay tunnel or some sort of kind of extra configuration, right? Because using internet, you cannot really talk to each other, or you cannot establish connectivity between remote sites, since they are using private addressing space, right? So if they are using private addressing space, obviously it is normal that those packets will get discarded by the service providers as they are carrying the private IP addresses. Obviously you could use some NATing and so forth, but that's a totally different scenario. But ideally, between the remote sites over the internet, the connectivity is not allowed, right? You can have access to the internet, but you cannot have connectivity between the remote sites. To have that, you needed to have some overlay tunnels to build, right? Either GRE tunnel, or maybe it could be IPsec or DMVPN, whatsoever, right? But now in Cisco SD-WAN, if you are having the internet connectivity, right, at remote sites, and you want remote sites to communicate with each other, again, they have to build the IPsec tunnel. They have to build the overlay tunnel. But this time in Cisco SD-WAN, since it is a controller-based networking, so all these IPsec tunnels will be configured automatically. You don't have to do anything manually. So that's one of the biggest advantages of using SD-WAN over to the traditional way of networking or WAN networking, right? Because in Cisco SD-WAN, everything is going to be, not everything, but most of the things would happen or would be configured by the controller, right? So you would see that most of the things are getting configured automatically in SD-WAN technology. Any questions so far about the requirement, the user requirements, right? Since it has got changed a lot. Okay. And let me ask question to Yogesh and Vinod. Do you guys still see any issues with the audio today? Like yesterday, you had some issues with the audio.
No, I'm okay.
Okay, perfect. Thank you.
Yeah.
Okay. So as I mentioned this yesterday, that obviously applications are moving to the cloud, and those applications are rich, dynamic, and web-based applications, right? And internet is moving to the remote side. I mean, this is what we saw, right? This internet is moving to the yes, and then business mobile devices. That concept has also, has been deployed by most of the organizations like BYOD, bring your own device, and then guest access, right? And obviously nowadays your applications need more bandwidth, higher bandwidth, right? And that's the reason that we require, even at homes, we are having 100 Mbps connection or maybe 200 or 300 sometimes. And some people are using 1 Gbps as well, right? That option is also available. So that's that. I mean, trends, the IT trend is basically is keeping on change, right? So you are, your requirements, the user requirement is also getting changed at same time. Well, if we talk about the Cisco SD-WAN solution, right, this overall solution, then remember that this Cisco SD-WAN technology is a transport independent technology. So when I say transport independent technology, which means that in underlay, right, or when we talk about the transport, because ultimately you have to get some kind of connectivity WAN connections, right? To go from one site to another site, right? Either you will be relying over the internet connection, or you will be relying over the MPLS, or maybe, even when I say 4G LTE, again, it is a kind of internet connectivity. So whether you are getting internet through the 4G LTE network, or you are having a broadband connection, or you are using a fixed leased line, doesn't matter. Internet is internet, right? And again, if you're using MPLS, that's okay. Like Cisco SD-WAN does not rely on a specific transport type. Okay, so it is a transport independent technology, and I would not really call it for Cisco SD-WAN only. I mean, in my opinion, if you talk about any other vendor specific SD-WAN too, they all are transport independent technology, right? So you can use any transport at this moment, right? So you can use either MPLS, you can use broadband internet kind of connection, you can use 4G LTE, and also you can use kind of leased line, right, for the internet connectivity. So you can use any transport. That's one thing. Sometimes people make the statement that will it really replace the MPLS, right? I mean, I have heard this question from so many different people. So now, usually nowadays, I cover this question by my own if nobody asks that question. So no, I mean, it's true at some extent, right? But it is not really. It is not really going to be possible in soon. I mean, in coming days. Actually, it's not really. I would not say that it is not going to replace either. Why? Because it has reduced the requirement of the MPLS connectivity, right? It has definitely hampered the MPLS kind of business for the service provider, because now customers are, let's say, service provider had a customer, right? I'm talking from a perspective of the service provider now, like from Airtel perspective, or from a BSNL perspective, or maybe from Geo perspective or Tata perspective, right? So earlier, if they had a customer who used to have, let's say, two MPLS connections, right? Now, if they are moving over to SD-WAN, either they are replacing both of their MPLS connections with internet, or at least they are replacing one MPLS connection with the internet. Like they would have MPLS and internet both, right? So obviously it is hitting that business, but it does not mean that it has completely replaced the MPLS. Since MPLS is a transport technology. So if somebody is still require a private connection between remote sites, then that's the only way to get the private connectivity, right? Either you get the MPLS connection or kind of metro Ethernet connectivity, right? So sometimes you would see that customers are also using the metro Ethernet connectivity, which in which you would get kind of layer 2 connectivity across all your remote sites, right? So either you will be relying over the metro Ethernet type of connection for having private connectivity between remote sites, or you would be using layer 3 MPLS kind of thing for having private connections between remote sites. But again, MPLS is still there. People are still using MPLS, so it's not like that SD-WAN has completely replaced the MPLS. But yes, it has hit that business really hard, right? And providers are really in pain nowadays because customers are replacing their MPLS connections with kind of broadband connection. Even nowadays you would see one more trend that if you have got kind of a small branch office, right? So you do not really need to pay for a lease line, okay? Internet leased line, ILL. No, you don't really have to pay for that. Instead of internet leased line, now customers are also preferring to use the business broadband, right? Because that option is also given by the service providers to their customers, right? That you can get a business broadband at your remote sites, and you can leverage that business broadband as a transport. So even the broadband connectivity is sufficient for the Cisco SD-WAN or for any SD-WAN vendor. But yeah, let's focus on the Cisco SD-WAN only at this moment. So in Viptela SD-WAN, even if you are using broadband connection at remote sites, that is more than sufficient. Which means that if I really talk about my home internet, like let's say I am having a broadband connection at my home, and if I have got a SD-WAN managed router, so I can easily deploy that. It will not create any problems for us, right? So I mean that is also possible. So I just wanted to say that even you can use the broadband connections to have the remote connections between, I mean to have the connectivity between remote sites. Okay. So transport independent technology, that's one thing, right? And this transport can also be known as underlay connection. You can also call it underlay connection. So for example, let me just draw some diagram here, okay? So even in earlier days, let's forget about SD-WAN. Let's not talk about the SD-WAN. So in earlier days, basically what we had, let's say we had site A, right? And then we had another site B, right? Obviously, either you would have MPLS type of connection, like you must have a transport, right? Or maybe you would have an internet service provider, right? At both ends. So this is your underlay basically, right? And then on top of it, you were building either IPsec tunnel or GRE, right? Or you would configure what? DMVPN, like all these options. So these tunnels will be called overlay tunnel. So this is how you can define these terminologies like underlay or overlay. So underlay is simply your transport, right? And overlay will completely rely over underlay connectivity. See, if your underlay goes down, obviously overlay connectivity will also go down. So overlay will always be depending upon the underlay connection. So these tunnels, right, whether you are building up the IPsec tunnel, GRE, or maybe you are using kind of DMVPN, where you can combine both, right? You can combine MGRE with IPsec. So these tunnels will be called or will be known as overlay tunnels. Okay, so that's how you can define these terminologies like underlay or overlay. So in underlay, you can use any type of transport like we have listed in this slide, right? So you can have either MPLS kind of connectivity, internet 4G LTE. That's one thing. Second, when we talk about the endpoint flexibility, which means we are talking about the managed routers. So these managed routers have to be installed across all branches, including data centers, right? So you will have to install them everywhere. So the kind of flexibility you get, that you can either install the virtual managed routers or the physical managed routers. So both of the options are available. Even if you are having kind of third party, let's say, I would call it let's say you have got a HP server or Dell server or IBM server, and on top of that you are using some sort of hypervisor. On top of that also you can build your virtual routers, or you can host your virtual routers, right? So that's what you could use, or that kind of flexibility you get when it comes to the VNage router. So you can have either virtual VNage routers or physical VNage routers. And then obviously, when we talk about the control components, right, such as you have got vManage, vSmart, vBond, these are the different components which would be participating in your Cisco SD-WAN architecture, right? So whenever you are going to deploy your Cisco SD-WAN for any customer, first of all, you would have to bring up, or you would have to host your control components. So when we talk about the control components, then there are some mandatory control components. So when I say mandatory control components, which means I would take their names as vManage, vSmart, and vBond. These all are the mandatory components. And apart from that, like you can see MSX is there, or NSO is there. Even when we talk about vAnalytics is also there. But those are all the optional components, right? So it's up to you or up to customer whether they want to use this vAnalytics or maybe they want to use this NSO, right? In most cases, you would see that this MSX or NSO, these things will be used by the MSPs, managed service providers, or maybe by the Cisco cloud team by their own, right? They will be using these tools to deploy the control components. So NSO and MSX, these components are mainly used to deploy your control components dynamically or automatically. So ideally, these tools will be used by the MSPs or by the Cisco itself, right? But these tools are not really applicable for a customer, right? But yes, if you want to deploy these components manually, you can get them deployed. Yes, Charanjit.
Yeah, so these MSX and NSO, they are above these
Correct.
vManage.
Correct.
With
Correct.
the help of this one, we can deploy vManage, vSmart,
True.
vBond.
True. True. I mean, it's all about the automation.
Okay. So
Yes.
they are upper level orchestrator.
Correct.
Okay.
It's like for firewalls, we have kind of FMCs. If you have heard about the FTD and FMCs, and on top of that, then you have CDO, Cisco Defense Orchestrator, right? So
Yeah.
using CDO also, you can manage like not only Cisco firewalls, but also non-Cisco firewalls, right? So that kind of thing you can say. Okay, so that's that. And apart from that, obviously, you can also deploy your VNage routers inside infrastructure as service, right? I mean, when we talk about the infrastructure as service, what is that actually? It is an infrastructure that you have built inside a cloud, like maybe inside AWS or maybe Azure, right? So inside Azure or maybe AWS, right? You can also deploy your virtual VNage routers. So the kind of advantage you would get, right, if you deploy your VNage router in that way, that even your branch users, let's say you have got a branch user sitting somewhere, they can directly access those applications hosted in Amazon cloud, or maybe in AWS cloud, or maybe Azure cloud, right? So they would have like direct IPsec tunnel. If that's the default behavior, but again, you can change that. You can you can convert your full mesh topology into hub and spoke, or maybe partial mesh kind of thing. Like you can always modify the topology when it comes to the Cisco SD-WAN, but in most cases, it would like by default it would remain full mesh kind of topology, right? So any branch router can talk to a router, or will establish an IPsec tunnel or BFD session directly with the router hosted inside AWS cloud. So if you have got couple of applications hosted in AWS cloud, so the branch user can directly access those applications without moving into data center. Because see, if you remember the traditional way of doing networking between between branch and cloud, so ideally what was happening in earlier in earlier days, that we were having a IPsec tunnel established between data center firewall and the cloud, right? So if a branch user needed to have access to the application which is hosted in cloud, that branch user was backhauled into data center first. From data center firewall, then you were going through the IPsec tunnel to your AWS cloud or maybe Microsoft Azure cloud. And that's and in similar fashion, it was coming back, like traffic was coming back. But nowadays things have got changed. because that would also cause some latency issue, right? Because you are backhauling everything into data center and then you are going into cloud. But now what Cisco has done, that even you can deploy your managed router inside cloud, right? Inside, I mean, which you call like infrastructure as service, right? So that's where you can deploy your virtual managed router, and those virtual managed route, like you would have to obviously provide internet connectivity to those virtual managed router. And as soon as you provide internet connectivity to your virtual managed routers, those routers can directly form an IPsec tunnel with the branch routers. And that's how the branch user can directly access those applications hosted inside your infrastructure as service, right? Or the public clouds. Isn't so? I mean, it's really amazing that, I mean, this is how things have got changed actually, right? So that's that. Now I will talk more about the SD-WAN components, right? So for that, let me discuss a couple of more things here, okay? So there are some benefits that you get post deployment, post SD-WAN deployment, such as one of them is lower WAN cost. Earlier you were using only MPLS. I mean, that example I have already given to you, right? But now obviously you can replace one of the existing MPLS connection with either business broadband or internet connection, right? So obviously the cost will get reduced, right? Now, apart from that, this is one another example, or this is one another use case of the Cisco SD-WAN, right? Service-based traffic engineering. Ideally, what happens is that if you have a data center, right? In fact, you can see that there is a data center in this slide, right? In data centers, you would have your app servers, correct? If somebody at branch level, let's say this user.
Do you have any PPT with without this logo, I-MEDITA logo?
No, I don't have that. No,
Okay.
I don't have
Because
such
it's,
PPTs.
yeah, I have to focus more.
Okay, so this user was actually accessing all these applications hosted in data center via this firewall, right? I mean, this is how the traditional networks, or even today, you would see that this is how the users would have access to the applications hosted in data center. That your end user would go to data center firewall, and then from that data center firewall, if user is allowed, if connection is allowed, then only you would have access to your application server inside data center, right? That's how things have been designed. But there is a small issue, or not a small, there is a major issue with this architecture. And what is that? Can anyone explain it to me? What is the issue with this architecture? That let's say this user, right, was not allowed to have access to the application which is hosted in data center, but at least still this user would go to data center, right? Because you have a routing in place, right? Since routing is already in place, this user traffic is going to reach data center, and data center, then it would hit to this firewall, and then firewall will block it, right? So obviously this user is using the bandwidth, the WAN bandwidth, overlay bandwidth unnecessarily, right? It is utilizing WAN overlay bandwidth unnecessarily, which is not required at all. Why this user is hitting to that firewall? You get my point? Exactly, exactly. So now either you should have the firewall installed at each and every branch. If not, then in Cisco SD-WAN, even if you are having a regional firewall, like you have got a regional DC where you can install a regional firewall, and there is a feature called service ingestion. There is a feature called service ingestion. Using that service ingestion feature, we can insert this firewall as a service for all other branches within this region. What we can do, that all users in this region will first come to this firewall. If this firewall allows, then only traffic will be forwarded towards DC. So now this user in this regional branch cannot access to those applications directly. So first they will go to their regional firewall, and from that regional firewall they will go to their data center. Obviously latency is one thing that you can say that, okay, there will be more latency. I agree to that. But at the same time, you are conserving, you are conserving your overlay bandwidth. You are saving your overlay bandwidth. So only legitimate users would be able to hit your data center firewall. So that way you can utilize that feature, right? So that's one feature that you could utilize. And of course, as I mentioned before, that nowadays you are not only performing routing based on layer 3 like we were doing earlier. Look at the IP header, open up the destination IP, perform lookup in the routing table, and switch the packet accordingly. It has been a traditional way of networking. Nowadays, even users are wanting, kind of routing at layer 7. Like, okay, I want this application traffic to go through this circuit or that circuit, that way, not based on just IP header and destination IPs, right? So things have become more application centric. Like customers are talking about the applications nowadays with the network engineering team. Earlier, it was not that usual, like I don't know, like people who started their career maybe 10 years back or 15 years back, at that point of time, nobody from the application team, they were not engaging actually the network team. The application team never engaged the network team. Why? Because network team was responsible to provide the IP connectivity between source and destination. And if application was not working or maybe some issues were there, then mainly networking team was not involved, unless obviously there was a firewall or maybe kind of proxies you had, or maybe some sort of load balancer you had. That was a different scenario. But from a routing switching perspective, then application team never engaged the routing switching team, because they knew that, okay, they don't have anything to do with that, since they are working at layer 3 only. And if you have got connectivity at layer 3, then obviously it is application layer problem or application team problem, right? It's not a network team problem. But now things have got changed. Even the network engineer who is responsible for doing routing and switching, they are also engaged, or they are engaged by the application team. Hey, can you forward this application traffic to this circuit or that circuit? Like customer would have that kind of requirement, right? So things have become more application centric. So your router should be capable to perform application aware routing. And yes, this feature is supported by the Cisco SD-WAN. You can create a group of applications, and for that group of application, you can define that, hey, I want to prefer internet circuit 1 or internet circuit 2, or I want to prefer, let's say, MPLS over internet or internet over MPLS. That way you can build your policies. Make sense?
So application based means we don't have to mention IP addresses or anything those kind of things.
Exactly. Just match your application from application list, and
but the application mostly application guy doesn't know what they want to transfer, right? So from a network perspective, we have to know what IP address, what ports we need to. Did application team also provide those things, or?
So it depends. So basically, Cisco has already added many applications in their existing application list. So mostly things should be okay from that existing application list. But in case if you need to add a custom application, then you would ask your customer that, okay, what is the IP address of the server, what is the FQDN, and what is the port number, what is the layer 4 protocol your application would use. So yes, if you are adding a custom application, then you would require all that information. But if you are using an application which is already part of your existing application list on your router, I mean to say, obviously you are going to create all policies from the vManage, right? So if your application is already part of that list, then you don't really have to ask all those questions to your customer, right? But at same time, when you are defining a policy, not only you can match applications, but also you can match source IP, destination IP, source port, destination port, if you want. But it is also sufficient to match your data based on applications. So again, it depends like how you want to construct your policy.
Okay.
So yes, that's that. And let's go ahead and secure segmentation. Yeah, this is one of the more feature that it supports. And this is, I would say that this is kind of feature which was supported by the Cisco SD-WAN in the beginning. I mean, Cisco, which means Viptela. It was only Viptela who supported this particular feature in the beginning. No any other SD-WAN provider. or SD-WAN vendor, right? Nowadays, you can see that it's been added by other vendors as well, but earlier it was a feature which was supported by Viptela only. So in this, what happens is that basically you can divide your network into multiple segments, such as you can take it in that way. For example, you have a PCI compliant network, right? I mean, within your network, you have got a network or a subset of the network which should be a PCI compliant, and then you have got a corporate network, and maybe you have got a guest network, and you want to segregate them from each other. You don't want to have a common network for all these three different types of, I would say, um, like ideally you would have a common network, right, or common routing table for everything, whether those are PCI compliant, or maybe your network is a corporate network, or maybe you are providing the guest access to your guest users, right? So for all these three different requirements, you would have a common network in most cases, right? But in Viptela SD-WAN, they had a feature called VPN, or you can call it VRF. Cisco calls it VRF. Viptela called it VPN. If you are creating policies or you are making configuration through the vManage, then you see only one option, which is VPN. But in backend, if vManage is pushing configuration onto C edges, then you would see in the configuration that it is creating VRF, not the VPN. But if it is pushing configuration on Viptela edge router, which is vEdge, then you would see that it will use a terminology called VPN. So here in Cisco SD-WAN, when I say VPN, just VPN, I'm not talking about the IPsec VPN. I'm just talking about the VPN. So VPN is always equals to a VRF, right? So in Cisco SD-WAN, it is mandatory for us to create the VRF, or to have the VRF. It is mandatory. It's not an optional thing, okay? So what you do is that if you have got different networks, as I said, you have got corporate network, you have got PCI compliant network, and then you have got a guest network, and you don't want to have a common networking for that, right? You don't want to have a common routing. So you want to segregate all of them from each other, right? So it is so easy to do that kind of segmentation using this feature called secure segmentation, right? Using VPNs. So basically you are going to use VPNs, also known as VRF, right? So for example, for corporate network, you can have one VRF. For guest users, you can have another VRF. And for PCI compliant network, you can have another VRF. And by default, no routes can be leaked. No routes can be exchanged between the VRF. And if routes cannot be exchanged, then how can you expect data would get exchanged between the VRF? So by default, no data, no routes will go from one VPN to another VPN, right? However, if you really want to have connectivity between the VPNs, you can do that. That option is available. You can perform inter-VPN routing, or you can leak routes between the VPNs, and that way you can allow communication between the VPNs. But by default, no traffic, no routes can move from one VPN to another VPN. Okay, so now there is a terminology called end-to-end segmentation. We need to understand that what does that mean actually. Okay, so let's assume that you have got a, let's say, corporate data center, which is a on-prem data center. Let's say it is a on-prem data center. And then you have got a branch you have got a branch, okay? And you have three different networks. Let's say you have got a guest network, then you have got a maybe PCI compliant network, and then you have got a corporate network. And then you decided to use a different VPN for each type of network. Let's say for guest, you decided to use VPN.
Network.
So when I say PCI compliant network, is that network where you would have only those machines where you are making your financial transactions, like POS machines and all that.
Okay.
So sometimes you would see that customers will have to follow the PCI compliance, right? Their network must be PCI compliant if they are making some financial transactions. Especially this is applicable for the banks, right? So then for PCI, let's say you decided to use VPN 20, and for corporate users, let's say you decided to use the VRF 10. So when I say VPN or VRF, it's the same thing. Now, earlier in Cisco, we used to create VRF by their names, like VRF IT, VRF HR, VRF, corporate, VRF this, VRF that. I mean, names were assigned to the VRF, but in Cisco SD-WAN, you would assign numbers to your VRF. Like VRF will be created using numbers like VRF1, VRF2, VRF3, VRF4. So that depends that which VPN number you have picked. So let's say if I said VPN 10, which means it would be creating VRF 10. If I say VPN 20, which means that it would be creating VRF 20, right? So that way your VRFs will get created. And let's say in branch also you had your guest users, right? Then you had a PCI compliant network, and then you had a corporate network, right? So again, you created VPN 30, you created VPN 20, you created VPN or VRF 10. Now, obviously, between data center and this branch router, they will be creating one secure tunnels using each available transport, right? They will be creating overlay tunnels, and those overlay tunnels will be by default secure tunnel, because by default in Cisco SD-WAN, it is going to use what? IPsec. So obviously, this data center router or data center managed router would establish a secure tunnel with this branch managed router, right? Okay. Thereafter, you would see that between data center and branch router, routes are getting exchanged for each VPN, which means for each VRF. And also traffic can go through this IPsec tunnel from one site to another site for each VPN. And that's what you could see, that using this IPsec tunnel, because this IPsec tunnel will come up, right, between remote sites, like between data center router and then the branch router, right? Using that IPsec tunnel, you are going to forward each VPN's traffic or each VRF's traffic, like VPN 1, VPN 2, VPN 3, right? And that way you are achieving what? End-to-end segmentation. That's the meaning of end-to-end segmentation. Because user, let's say I'm a corporate user at branch level, right? I'm part of the VPN 10, which means VRF 10, right? So user is sitting at branch and it is part of VPN. I mean, this user is part of VPN 10. Similarly, you have got some resources hosted in your data center, which are part of VPN 10. So this user can have access to those application or to those resources only inside data center, which are part of VPN 10. Which within VPN, you can have connectivity, like intra VPN communication is always allowed, but inter VPN communication is by default blocked. It is not possible, right? However, technically, if you really want to have that kind of connectivity, let's say you wanted maybe some of the corporate users to have access to that application, which is hosted inside PCI compliant VPN, right? So again, you can perform route leaking. You can leak routes from one VRF to another VRF, and that way you can also have, or you can obtain connectivity in between them. Exactly. It is. In fact, if you talk about the traditional MPLS connectivity type of thing, in MPLS, we used to have BGP, VPN, V4 implemented, and, we used to create multiple VRFs. So we had same concept in layer 3 MPLS VPNs, right? So like where by default routes will never go from one VRF to another VRF, or I would say from one VPN to another VPN. But we could again leak the routes between the VPNs in earlier days. And we have got the same concept over here in Cisco SD-WAN as well. So it's kind of similar concept that we had before in Cisco networking, especially when we deployed MPLS L3 VPNs. So if somebody understands that concept, then probably they can easily understand this concept as well, which we are using here in Cisco SD-WAN. So what I wanted to say that yes, it does end-to-end segmentation, which means traffic would remain within VPN. Your routes would remain within VPN across the branches. Any questions so far?
So to break out that VPN, what is that exactly called, sir? Like inter VPN.
Say again, inter VPN what?
To break out the
Also,
routes between the VPN, what exactly the term called?
Inter VPN routing.
Okay.
Yes.
also, sir, it would be great if you could explain the exact difference between inter and intra VPN.
So if there is a, let's say at branch level, you have got 3 VPNs, right? So VPN 10, then you have got VPN 20, and then you have got VPN 30. And similarly, you have got in data centers VPN 10, right? Then you have got VPN 20, and then you have got VPN 30, right? So if there is a user in VPN 10, right, inside data center, and there is a branch user which is also part of the VPN 10, so these machines can talk to each other, right, within VPN 10. So this is called intra VPN. Does that make sense? Now let's say inside data center you had a user part of VPN 20, right? But the user inside VPN 10 at branch level also wants to have access to that resource which is available inside VPN 20. Now you would call it inter VPN. So one is intra VPN, right? The second is inter VPN. Make sense?
So this all comes under the Cisco umbrella. That's it. Why done with
No,
GUI?
that's totally different concept, right? This Cisco umbrella is totally, forget about that. This is Cisco umbrella is totally different than what we are talking about here.
Okay.
Because Cisco umbrella is a cloud delivered security solution, right? So
these features are all done by manually, right? This secure segmentation.
yes.
Saurabh,
Yes, sir.
within a branch, we can also do inter-VLAN routing, right? Or
That is
inter-VPN routing.
correct. Yes.
So in that case, the branch user has nothing to do with the data center. He's not required to come back to data center,
No,
right?
nothing. No. Within
Okay.
branch also you can perform intra VPN routing if needed.
Okay.
Yeah,
Okay.
that is also possible. Okay, cloud ready WAN. So as I mentioned that you can integrate your on-prem branches with the infrastructure as service, as I mentioned this before, because inside AWS and Azure, it is really possible to deploy the virtual WAN edge routers and to have direct IPsec tunnels with the cloud data center. So that way, if there is a user sitting at a branch, that user can directly access those applications hosted in your cloud data center. So yes, it is a cloud ready WAN. And on top of that, Cisco has also automated this whole stuff. Like if you have access to the vManage, but you don't know that how to work on AWS, how to work on, let's say, Azure, you don't know anything about that. You never heard about the VPC, nothing, right? But still you want to deploy your managed routers. You want to integrate your your cloud data center with your rest of the network or this secure SD-WAN fabric, right? If you have access to the vManage, you can follow the deployment guide, right? And on Cisco vManage itself, you can deploy your managed routers inside either AWS cloud or in Microsoft Azure cloud. That is also possible. So if somebody like, let's say, let's take an example of myself, right? So if I don't understand Azure, if I don't understand AWS, still I can deploy things. Still I can deploy virtual managed routers inside the cloud using vManage, right? So I don't really have to log in onto AWS portal or maybe Microsoft Azure portal. So that's another advantage that you get using Cisco SD-WAN. Obviously, this feature is provided by mostly all of the SD-WAN vendors. But yes, Cisco also provides that, right? Or Cisco has that feature as well. Then obviously, for better user experience, you can enable kind of DIA, direct internet access, for the SaaS-based applications, and that too with performance monitoring, right? So with performance visibility, you can enable DIA for SaaS-based applications. Like if you have got an internet connection at the branch itself, let's say you got the internet connection at branch. So the kind of policy you can build that, hey, for Office 365, forward traffic directly over to Office 365 using internet circuit, and provide access to the end users for Office 365 directly. Don't go to any data center. Don't perform any kind of backhauling. Maybe we did backhauling for the entire internet access through the data center, right? But then at the same time, I just want that for my SaaS-based applications, we should be doing direct internet access, or we should be using DIA. So if you have got like even multiple internet connections at the branch level, and you want to leverage like that internet connection which is performing best at the moment, so that kind of policy is can be built over to this branch router. I mean, you have got so many advantages. So because see, what happens is when we talk about the Office 360, what is it? Office 365 is deployed by the Microsoft somewhere in the cloud. Maybe it is part of the Microsoft Azure. Now, different providers like Tata or maybe BSNL, ideally they have direct connection from their data centers to the Microsoft data center, right? So sometimes you would see that Tata is performing well. Sometimes you would see that Airtel is performing well, right? So these managed routers are enough capable, right? You can build the policies so that these branch routers can monitor the performance of each internet connection, that okay, which internet connection is performing well in regards with Office 365, right? So the link or the internet connection which is performing best, that would be selected by your branch router to provide the access of the Office 365 for your lane users. So that kind of flexibility, or that kind of I would say feature list it provides you. So that kind of feature it has. So you can always go back and build those types of policies, and we would build them. We would build these policies that, hey, I want to implement DIA, direct internet access, for certain SaaS-based applications, but at the same time, I want to use that link which is performing best at this moment. So then you would see that your managed router would start sending HTTP ping. They send basically what? HTTP ping. Like this is a new concept of doing pinging, right? So managed routers would start HTTP ping to the Office 365 servers, and then using HTTP ping, they can measure the performance of each available internet circuit, and then they can forward the traffic over to that circuit which is performing best at the moment, like where it gets low drop and low latency, low delay, right? So it would select that circuit basically. And this feature would be added to the Cisco firewall sooner. So far, it is not part of the Cisco firewalls, but sooner, maybe they are going to launch a new version for the firewall operating system, which is 7.4. And with 7.4, they would add, like Cisco is going to add this feature onto Cisco firewalls as well. So far, it is not available on Cisco firewalls, right? Well, that's that. And then for management,
Saurabh,
yes, sir.
One question. So you said this feature is about to be introduced on the firewall. You are talking about SD-WAN, right?
In SD-WAN, it is already there. I just made that additional statement. In Cisco SD-WAN, it is already there, right? But when I say firewall, which means I'm talking about the Cisco Firepower, the FTDs.
Okay. Cisco firewall does not have SD-WAN capability like the Palo Alto. Is
True.
it correct?
Yes.
True. Yeah. Okay. Okay. One more question. Like when I have enabled DIA for my Office 365 services, right? Now, let's suppose, assuming that I have two internet connections, one IP, one internet, and I have MPLS towards the data center, right?
Yes.
Now, in case, again, just hypothetical, let's suppose both internet and the LTE are performing bad. So is it possible that I can take the MPLS route also to Office 365, or DIA will not be using MPLS at all?
So that's a good question actually. So there are actually two separate things in Cisco SD-WAN, right? One, configuring hard-coded just DIA, and in which you cannot really apply those HTTP ping, or you cannot really measure the performances of your internet circuit. So in that situation, or with that policy, you get that feature where you could say that, hey, if both of my internet connections are down, then it should fall back to the MPLS, then it should get backhauled into DC, and then we should have access to the application using or via data center. Make sense? But if you are deploying Cloud Express with for the SaaS application, SaaS based application, in that you don't get that option. So to implement DIA, again, you have got two separate methods in Cisco SD-WAN. One, using Cloud Express. Second, just by building up some data policies, right? So if you are building up data policies to configure or to implement DIA for certain applications, in that you would get the option that you are talking about, Naeem, right? That you can use the fallback method, right? Like it can follow the MPLS, and then it can go to data center, and then from there you can have access to your applications. But if you are implementing it through the Cloud Express feature, then you do not get that option.
Okay, and the Cloud Express is not Cisco umbrella. It's Cisco SD-WAN, right?
Yes, it is a Cisco SD-WAN.
Okay.
Cloud Express is nothing, but it is cloud on ramp. Like Cisco has renamed it. Viptela called it Cloud Express, but Cisco calls it Cloud on Ramp for SaaS, or Cloud on Ramp for infrastructure as service, or Cloud on Ramp for multi-cloud, or Cloud on Ramp for colo, like that.
Okay. All right. Great. Thanks.
So simplify WAN management. Obviously, you're going to have vManage, right? So to have visibility to your network, how many devices up, down, the performance statistics, top applications, and all those things will be visible through the vManage. But also you can have access to the vAnalytics in case if you want, but it works based on opt-in model. So if customer is opting for the vAnalytics, then only they would have access to this vAnalytics. And remember, this vAnalytics is totally cloud-based, SaaS-based application, I would say. So customer will have to subscribe the subscribe this vAnalytics service. If they do not, because it works based on opt-in model, which means it is not a compulsory or mandatory component of Cisco SD-WAN. It's just that it would help you to get the rich analytics, or I would say interactive reports, so that you could showcase them to your higher management. Because that kind of help you can get from the vAnalytics. You can make some futuristic I would say assumptions, right? That okay, this is the amount of bandwidth that this branch router is utilizing at this moment. So obviously in future, and in the time of three months, like we have, the utilization has been increased from, let's say, 10 Mbps to 15 Mbps. So obviously we are assuming that in next 3 months, probably we would require 20 Mbps. It is just an example. So that way, by looking at the vAnalytics, you can try to make assumptions that, okay, this is how much amount of bandwidth you would require. This is the application that is being accessed by the end users mostly, right? So you can build your policies accordingly then. But it is just to give you the visibility, that's all. And to generate the interactive reports, that's all. You cannot make any configuration, you can't perform any troubleshooting, nothing. You can't do anything with using vAnalytics. It's just that it can generate some interactive reports, that's all. But yes, vManage is obviously is gonna be required, right? You would be doing everything from the vManage, whether it is troubleshooting or you are making some configurations onto your managed router. So everything would be done by the help of vManage only. So that's that. Now, integration plan, forget about it. We will talk about this later. So now let's focus on the SD-WAN architecture now, right? So in this Cisco SD-WAN architecture, I kept saying that, okay, you have got managed routers, then you have got some control components like vManage, vSmart, vBond, and vAnalytics is also there, right? But vAnalytics is an optional thing, right? It is not mandatory component. It is not necessary for you to keep or to have the vAnalytics in Cisco SD-WAN, right? The transport is going to be independent, like still it is kind of MPLS, Internet 4G LT. You can use any one of them, any two of them, any three of them, any four of them. You can have up to 8 WAN connections that you can terminate on a single WAN edge router. So that's the maximum limitation that Cisco offers. I remember that some other vendors, they do support up to maximum 4 WAN connections that you can terminate on a single WAN edge router. But in Cisco, you get that flexibility for up to 8 WAN connections that you could terminate on a single WAN edge router. Although I never saw that. I never saw any customer using 8 connections or terminating 8 different connections on a single WAN edge router. But yes, that kind of capability your WAN edge routers would have in Cisco SD-WAN, right? But now let's talk about this, all together at top, all these components are like kind of brain. If you look at this image, it indicates that it is a kind of brain of this SD-WAN architecture, right? All these components together, right? So yes, vManage, vBond, and vSmart controllers, right? These are the three major control components. These are major 3 control components. So these all are the controllers, SD-WAN controllers in Cisco SD-WAN architecture, right? So you have got vManage, you have got vSmart, you have got vBond, and each one of them would have different functionality. Okay, and I'm going to explain all those functionalities as well for each individual control component. Just wait for another couple of minutes maybe. But yes, in Cisco SD-WAN architecture, you have got its brain, and within its brain, it's vManage, vSmart controller, and vBond. vBond is known as orchestrator, okay, or you call it orchestration plane. And then vManage is also known as management plane. And then vSmart controllers also known as control plane. And this is one of the biggest advantages of having Cisco SD-WAN or any, this is the biggest advantage of having the SD-WAN technology in place. Why? Because you have got a centralized control plane. You have offloaded the control plane functionality from your WAN edge routers to the vSmart controllers, right? Now let me give you one example here, okay? Earlier we had like kind of control plane functionality performed by each individual router locally, right? That's what we had. So if you had like maybe 500 branch offices, okay? In each branch, you were using BGP as a protocol, right? You were using BGP as a protocol. You had maybe 2 WAN connections. One was primary, the other one was secondary. And you created a policy for that, BGP policy, which means that you created some sort of route map. Now, since you build all those policies for all 500 branches and everything was working perfectly fine, and I gave this example even yesterday, that if now you have got a requirement where you need to change your primary circuit, right? So obviously you would have to modify your BGP policy, isn't? On all 500 routers, you need to go to each and every branch router individually. You need to log in there and you need to modify that policy that you applied on all those 500 routers. Okay, you would have to do that. But since in SD-WAN, you have got a centralized control plane, because see, earlier for all 500 branches, we had individual routers for all 500 branches, and each individual router was running its own control plane. And that was the reason that you needed to make the policy changes on all routers individually. But since in SD-WAN, you are having a centralized control plane, so you go to vSmart controller, you define the policy on vSmart controller that this is the circuit that I want to define as a primary circuit, and you are done. So you you made the changes on vSmart at one place, but it has affected all 500 branches at the same time. So it has simplified the control plane functionality. It has reduced the complexity of your control plane by having a centralized control plane. But yes, at the same time, it has increased risk as well. It has increased risk factor. How it has increased risk factor? Because let's say you made some changes, right? It might affect all 500 branches. And let's say you made some wrong changes. Let's say you were doing some sort of route filtering and you applied your changes in wrong manner. So if there is an outage, then there is an outage for all 500 branches at the same time. So yes, it has increased some risk factor as well. But yes, it is so easy for you to roll back your changes as well at same time. So it would not be that much harmful for you. I would provide my recommendation that how you should modify your policies onto vSmart controller. So you don't really have to worry. But since you are having a centralized control plane, it has reduced complexity, but it has added some risk factor to it, right? One more thing, you must not be having a single standalone vSmart controller. No, never. You must always have multiple vSmart vSmart controllers. Why? To have redundancy in regards with the control plane, because obviously control plane must always be up and running. But somehow, let's say this is another advantage of Cisco SD-WAN. Let's say somehow due to any reason, all of your control plane went down, like the entire control plane went down, which means that all of your vSmart controllers went down. So your control plane is down now. Earlier, if you take an example of the traditional networking, what happens if the control plane goes down on your router? What could happen? Yeah, why will it not forward your traffic? Because as soon as control plane goes down, which means the routing table will get crashed, right? RIB will be removed, right? If control plane goes down, and immediately FIB will get removed, the forwarding information base, right? So that would also get removed, or it will lost all routes from its FIB, and that's how it will stop traffic forwarding, right? But if you used like high-end routers like ASR routers, or maybe if you had 4500 series of switches where you could have multiple supervisor engines, which means multiple control planes, where in case if one of the control plane, which means one of the supervisor engine goes down, then you have got another one, and then you could implement SSO kind of thing, which is stateful switchover, right? So in which there will not be any outages. But those were applicable only for the high-end routers like ASR series of routers, or 4500 6500 series of switches, or maybe Nexus switches, 9K series of switches, right? So we could apply those solutions to those high-end devices only. But in Cisco SD-WAN, even if you are using a branch router, a low configuration router, a single router, and let's say your entire control plane went down, like vSmarts went down, ideally your data plane devices, because in data plane you would have your managed routers, right? So ideally your branch routers should stop data forwarding, right? But it doesn't happen in case of Cisco SD-WAN, right? It doesn't happen. What happens is that your branch router can keep the previous, or the last best routes in its routing table. Even if your control plane is down, still it will keep those routes for next 12 hours. And I believe that you can configure it up to 7 days, right? Ideally, in production environment, we don't change it. And even if we change it, then we make it 24 hours, right? So if your control plane connection from a managed router goes down, like the connection with the vSmart goes down, still your managed router will not lose its routing table. It can maintain its routing table, the previous best routes for next 12 hours. That's the default functionality that you get onto Cisco managed routers. Okay, so that kind of feature you get in Cisco SD-WAN. So even if your control plane goes down, there is no impact on the data plane connectivity, because see, the data between remote sites would get exchanged between the remote sites using these secure IPsec tunnels, and this is called data plane. In data plane, only managed routers are participating. Remember that your user traffic, actual traffic, will never ever pass through any one of the control component. Will never ever. I'm talking about the user traffic. Only control plane data. Only control plane data will get exchanged between the managed routers via control components. Like for example, if you have got a couple of routers at campus, and then you have got a couple of routers at branch, and they needed to exchange their routes information, their lane prefix information, right? So they would exchange that information via vSmart. So that would get exchanged via control plane, right? Only control plane information. But whenever traffic is going to be exchanged, like there is a user in the branch, and then maybe there is a print server, or maybe some applications hosted at campus, if this user is trying to access that application, then the traffic will come through IPsec tunnels to the campus routers directly. These IPsec tunnels will get established between the managed routers only. So user traffic will never ever go through any one of the control component. User traffic will always go from one branch to another branch using these IPsec tunnels only. And these are secure connections, right? So you would have a secure data plane connectivity between managed routers. So your managed routers would always participate in the data plane. Whereas for control plane, you have got dedicated vSmart controllers. I mean, ideally, these control components will never go down, but I just gave you one example. Let's say you deployed the on-prem controllers. You're deploying what? On-prem controllers, and you had just one data center where you hosted all of your control components, and let's say something happened to your data center and all of your control components went down. Let's say vBond, vManage, vSmart. Still, there will not be any impact on the existing connections. Obviously, you cannot introduce a new router, or maybe one of the managed router got restarted again. That router will not become the part of the fabric, right? Or will not be participating in data plane. If it got restarted, you will not be able to enforce any new policy. You would not be able to make the configuration modification. You cannot modify your configuration if all of your control components are down. But there will not be any impact on existing data plane connectivity, which means that user traffic will keep going between the branch offices, right? Or from branch to data center and vice versa, right? So that's one of the biggest advantages of using this kind of architecture, right? I remember that one of the customer was using Velo Cloud, right? And they had VCP, and that VCP somehow went down, and all their 500, or maybe I don't exactly remember that how many different sites. I believe that was 200 or 500, somewhere around that. All their sites went down at same time. So that has happened. I mean, I do remember. I don't know the this Velo Cloud SD-WAN. I never worked on that. I never deployed that SD-WAN solution, but that's what I came to know from one of my colleagues, right? So he mentioned that, okay, this is what happened to that customer. Then I said, okay, it is not possible in Cisco SD-WAN. Why? First thing is first, that in Cisco SD-WAN, we are using distributed architecture. We have a different orchestrator. We have a different management plane. We have a different control plane, right? Ideally, you would see that most of the SD-WAN providers are having an integrated controller. Just one controller performing everything. That one controller is working as a management plane, that same controller is working as a control plane, and same controller is working as an orchestrator, not data plane. For data plane, obviously they would have different managed routers, but yes, when it comes to the controller, they have kind of integrated solution. But Versa, if you take an example of Versa is also using kind of similar approach. They are following the similar approach as Cisco. Like, they have distributed architecture. They have different management plane, they have got different orchestrator, they have got the different control plane, right? But if you talk about like maybe Juniper, right? In Juniper, we have a single controller, right? Or a combined controller for all these three functionalities, right? And then we have got a single controller in case of Velo Cloud, and then same controller in Silver Peak, right? But in Cisco, yes, you have this distributed architecture. So you have got different components for different functionalities or different functions, right? Remember that all these control components are virtual components. You cannot ask Cisco that, hey, I need physical vManage, I need physical vSmart. No, that's not possible. These all are virtual components, right? vBond would be exception, right? vBond would be exception, obviously. Why? Because vBond is not a separate device, is not a it's not using a different operating system. It's a managed router actually. Your vBond is a managed router. So when we talk about a managed router, it can be either virtual and also it can be a physical. And therefore, since vBond is a managed router, right? But we have to define that, hey, you are a managed router, but you would be working as a vBond, right? So that's what we do. Like, when we are going to define a managed router as a vBond, we have to execute one command which tells a managed router that it has to act as a vBond, as an orchestrator, right? So vBond can be either virtual or physical. But apart from that, like vManage and vSmart will always remain virtual devices. There is no option to have them as a physical device. And if you are insisting Cisco to have a physical vmanage, what Cisco can suggest you that, okay, purchase one UCS server and deploy it on top of that, right? Like ICE, they do for ICE, right? Identity Service Engine, or maybe DNAC, right? So in similar way, they can sell you UCS server, and then on top of that you could deploy your vmanage. But these all are the virtual components. In fact, vBond, it can be a physical router, but it is never recommended to have it as a physical router, and there is a reason, technical reason behind that. Since vBond is never going to participate in your data plane, then what would you do with the physical device then? Obviously physical device would come with higher with higher CPU cores and then memory. I mean, it would be a performance, it would give you a good performance if you're using a hardware, right? But my question is that why should we use the hardware if this device is never going to participate in data plane? If it is not going to handle your user traffic, then what is the advantage of spending that much money on a hardware vBond? And that's the reason that in most cases, you would not see your vBond configured as a hardware device. If your customer is having enough money, fine. If Cisco wants to make more money, they can suggest customer to have vBond as a hardware device. It is possible.
So what about vAnalytics, sir?
vAnalytics is all cloud delivered, right? For vAnalytics, even you don't get a VM that you could install on top of some KVM or hypervisor, right? It is provided by Cisco as a SaaS.
Okay.
Okay.
So it's to measure the performance and to analyze the traffic and all.
That's it. That's it. Like even this vAnalytics tool is going to fetch the information or statistical data from vManage using REST API. That's all it does. Okay, and all your managed routers would be exporting telemetry data to the vManage, and then vAnalytics fetches that data from vManage. That's how vAnalytics would display you all the statistical data, or you can generate reports from the vAnalytics tool and so.
This vAnalytics is related to which component in the SD-WAN fabric?
No, it is called vAnalytics only. It's a SaaS-based tool. And
okay,
it is called vAnalytics.
Then.
Yes, that's why that's what I made one statement, right? That it is an optional component. It is not a mandatory component in Cisco SD-WAN.
Okay, so it doesn't matter if it includes better performance. We use it, right?
For creating your reports, interactive reports, yes, I would suggest to keep vAnalytics.
Okay. This API is the third-party automation. So who's are the third-party automations? No.
See, that's one first thing is first that I'm not going to perform any API integration here. That's one thing. Second, you should be knowing that APIs are supported by vManage. The REST APIs are supported by vManage, right? Even I don't know if I discussed this yesterday, but yes, you can use that REST API to perform the integration with third-party tools or third-party applications, such as your ServiceNow, right? ServiceNow is a third-party tool. Now you can integrate your ServiceNow with the vManage. Why and how? Let's say, obviously, one of the interface went down at the managed router level, right? So obviously, it will generate one event, and that event will be exported to the vManage by default. Now, vManage would see the severity level of that event and might generate an alarm, an alarm against that, right? So against that event, or it will convert that event into an alarm, right? At same time, using REST API, we can create an application right here on ServiceNow that in every 2 minutes or maybe in every 5 minutes, please go and look into event bucket. Look into event bucket. If you see any event related to interface down or interface up,
so then it generates a ticket.
Fetch that, right? And then ServiceNow should generate a ticket against that. And it should assign that ticket
tool, right?
DL, right? Distributed list, right? Obviously.
So this is a ticketing tool, no, sir?
I'm sorry.
This is a ticketing tool, right? The ServiceNow.
ServiceNow, yes. ServiceNow is a ticketing tool.
So
So
the
this is
very
just an example that how you could integrate your third party tool with
got
a third
got it,
party
got it.
application with the vManage using REST API. So using API, not only you can look into the event bucket, also using API, you can detach the devices from the templates, right? Also, you could look at the device statuses, right? I mean,
Current
status and
Currently we're using NMS, no sir. Backend in the service now under other applications we're using NMS, right?
see,
To get that.
vManage itself is NMS in Cisco SD-WAN. You also
Okay,
call it NMS.
okay, got it.
Because everyone is exporting telemetry data to the vManage, and that's why we are also calling it as a network management server or network management system, right? So your
Yeah.
vManage also known as NMS. Why? Because all of your other components, whether those are vSmart controllers or vNS routers, everyone is exporting their telemetry data to the vManage using netconf. They don't use SNMP, instead they use what? Netconf. So using netconf, the vNS routers would be exporting its data to the vManage, and vManage is working as a collector, which means as NMS. Does that make sense?
Got it, sir. Do
Now
we need
from this
like backup for
NMS,
vManage? Like could
uh,
this standalone is enough for vManage?
no, I mean, obviously, that's something that we would be discussing later, right? But yes, to answer your question, you must not be having a standalone vManage. You
Got it.
must have at least, a cluster of the vManage. And not only that, but also now in vManage, Cisco has added a feature called persona, called persona. Earlier, we had that concept of personas for identity service engines only. But now Cisco has also introduced that feature with Cisco vManage. So with persona, like basically within vManage, you have two different personas, right? One is to maintain the database. The second is to build the policies like for the administration purposes and all that, right? So what you can do, you can have like maybe I mean, you would have like multiple vManages, like you would have 5 vManages or so, right? And then you can define that, okay, these 3 vManages I'm going to use for database, and these 2 vManages I'm going to use for admin purposes or for policy creation and all that, right? So that way you would get not only you would get load balancing, but also you would get redundancy, right? So that way we create the cluster for the vManages. So yes, vManage supports the clusters, and that's how we should build it. We should always make a cluster of the vManage. So in case if one of the vManage goes down, you have other vManage up and ready.
So the both work will be done at the one vManage in case if the backup will go, the redundancy, like data
Yes.
and policy works under one, right?
He, so basically for data, you should have at least 2 vManages, and for policy also, you should have at least 2 vManages.
But in case if it's go down, like who will take care of policy?
The other vManage that you had, as I said, at least 2 vManages for each persona.
Okay, got it. Multi redundancy.
Yes. Okay, and then let's talk about the data plane. So obviously you have got the VANEDGE routers, right? So VANEDGE routers will always be
Saurabh,
participating in data plane. Yes, sir.
just a question. What are the hardwares currently in use for hosting these controllers and vManages?
So first thing is first, the Cisco, and in fact, being a part of MSP, we always recommend customers to host the controllers in cloud. That could be either AWS or Azure, doesn't make any differences, right? So you can pick any public cloud and then you can host all your control components inside cloud. But if you're looking to deploy the controllers on-prem, this is what we are going to perform. So in most cases, you would be using either KVM or ESXi, and you don't require any specific hardware for that. You can have either HP server or Dell server or IBM server. So you can use, or maybe even, the Cisco's UCS servers, right? So on top of that, you can deploy your all these control components, right? So,
Okay. We do not have any Cisco
Cisco
manufactured
Cloud?
hardware?
no.
No. Okay.
The
Okay.
only thing
Can
you can
we,
ask Cisco right? The only thing that you could ask Cisco that, hey, can you deploy these controllers on my behalf, right? So Cisco will charge you for the deployment or, for deploying all these control components. And Cisco says that they have their own cloud, right? But in actual, they don't have their own cloud. They use either Azure or AWS, right? And that's where their cloud operations team will be deploying these controllers for you. What you have to do is that once you request Cisco to deploy your control components, thereafter Cisco would provide you an access to one of their portal. On that portal, you just have to fill in that how many vManage and how many vSmart and how many vBond you need. As soon as you submit that form, in next 10 minutes you would get another email that, okay, these are the login credentials, because in backend their NSO would work and will deploy the control components for you in cloud. Make sense?
What about the Cisco Meraki, is a cloud based, so can we use for
Meraki is
that?
a different thing, right? There is no correlation in between Meraki and this Viptela SD.
Okay.
Yes.
How about the currently, like Cisco has introduced CSPs, right? They are recommending CSPs as well for the hardware.
Can you
Cisco CSPs.
like what is Cisco CSP? What it stands
I
for?
think it is I'm not 100% sure, but it is like a
It's a
cloud
cloud
Cisco
services they are offering.
yeah, cloud services platform. There's a hardware, and Cisco is selling this product. I don't know whether it
It's a
is for
platform collector,
vSmart.
Cisco service platform collector.
Yeah, so this one Cisco is in
I
really
have not really heard about that.
okay.
Um, I,
So like in our environment, we
mhm,
have head ends, right? SD-WAN head ends.
mhm.
I'm just wondering, when we call them head ends, are these controllers or these are also the managed routers?
Headends should be your managed routers only, not the control components.
Okay,
And these are
so
just terminologies. You need to understand them, right? These are the terminologies used by the Cisco professional teams, professional services teams, right? So not sure that whether they are calling head ends as a control components, or in my opinion, it should be only managed routers. But these are just terminologies used by the professional teams,
yeah, because
professional
I'm sorry,
services. Mm.
yeah, I'm sorry if I'm taking some time here, but in our environment, we have like in our data center and in our co-location, we have some head ends, right?
Mm-hmm.
And all the branch managed routers are like having IPsec tunnels to those head ends. So that's what I was wondering. Is it like head
So
end is
headends
the
and nothing is just, so those are just managed routers. You don't need.
then probably there will be a couple of more head end routers, like
Yeah,
managed
of
routers.
course.
Okay.
So management plane, or you call it vManage, right? So let's talk about all these control components individually now, right? So vManage is a management plane, and remember that this Cisco vManage is the most intensive or hardware intensive device. Like it would require the most number of CPU cores, most number of memory, and then of course the storage, right? So this Cisco vManage, let's say if you are planning to deploy the Cisco vManage, then ideally you should have either 16 CPU cores, minimum 16 CPU core for the production, right? And then you should have 32 GB of memory, and then you should have at least 500 GB of storage. Basically, vManage would require two different hard disks or two different storage disks, one to install its operating system, and the size of that disk should be around 20 GB. I mean, it should be 20 GB. That's one hard disk. The other hard disk would be used for the storage purposes only. And the size of that storage disk should be minimum 500 GB. Although based on availability, you can pick it up as 1 TB or 2 TB as well, like if you have the available storage. But if not, then minimum you should have the 500 GB, right? So that's one thing that you should know about the vManage, right? Now remember, it is a single pane of glass for day 0, day 1, and day 2 operations. So what does that mean? So basically, you can use this vManage for design purposes, not only for design purposes, but also you will be using it for making the configurations onto your devices, like for the configuration purposes. And third and last, also you would be using it for the troubleshooting purposes. Like once your project is handed over to the operations team, even operations team would be doing troubleshooting using vManage. So not only from planning, designing and planning, right, but also you can make the configuration, and also you can perform troubleshooting. So all like day zero operation, day one, day two operations can be performed from this vManage. Everything can be performed this using vManage. So having access to vManage is really essential, whether you are performing troubleshooting or you are trying to make the configuration onto devices, or maybe I mean, obviously for design it is not really that much essential, but yes, you can also perform, like you can create a design on your vManage, right? That option is also available over there. So then it can also be configured in multi-tenancy mode. So for example, you are working as MSP, like being a MSP, right, managed service provider, this feature is really important. Why? Because sometimes you would see that you would have a small customers having like 2 branches, 3 branches, or maybe 5 branches, 10 branches, right? And they are not in a situation where they can, pay for dedicated vManage, because see, vManage is a hardware intensive device, right? So it would require lots of hardware resources, right? So obviously if you are deploying vManage in AWS cloud, so you can think of that how much bill you would get on per monthly basis, right? So sometimes customers will not be willing to pay that much amount, right? So to reduce that cost for those small customers, there is a concept of multi-tenancy, that you can deploy your vManage in multi-tenancy mode, right? So where you can utilize a single vManage for multiple customers. Now remember that all these control components do not support multi-tenancy. It's just vManage and the vBond. It's just vManage and the vBond that you could convert into multi-tenancy mode. By default, when you turn on or power on vBond or vManage, by default, these devices will boot up in single tenancy mode only, which means you would have a dedicated vManage for a dedicated customer, right? But then you can change them into multi-tenancy mode, right? So multi-tenancy is supported by vManage. The centralized provisioning, right? So when I say centralized provisioning, which means that you are going to provision everything from vManage, whether you are provisioning your managed routers or maybe other control components, you are going to do that provisioning from the vManage. The policies, whether those are data plane policies or control plane policies. So ideally, when I talk about the policies, you would have 2 separate types of policies supported in Cisco SD-WAN. One called control plane policies, the other called data plane policies. So using control plane policies, you can perform like kind of route filtering, path manipulation. So for that purpose, you would be using control plane policies. For data plane data plane policies would be utilized by you to implement kind of PBR, policy based routing, for certain applications and all, and so, right? So for that purpose, you would have data plane policies. So all those policies would be created onto vManage, and you would be pushing them onto either on vSmarts or managed routers from the vManage itself, right? So and same goes with the configuration templates. So even the configuration templates would be created on your vManage itself. So you would be creating configuration templates onto vManages, and you would be attaching your devices to those configuration templates onto vManage, so that your vManage can push the configuration onto your managed routers. And not only you can create configuration template for managed routers, but also you can create configuration templates for your vSmarts, for your vBond, and even for vManage itself, right? So you can create those configuration templates onto your vManage, and then you can attach devices to those configuration templates. So configuration templates are nothing but those are a way to make the configurations onto devices. So you would be making the configuration onto devices using configuration templates. It's a GUI based method, I would say, right? I mean, obviously, I would not really make that statement that it is a GUI based mechanism or GUI based method for making the configuration, because you can have both types of configuration templates, like CLI based templates as well as the GUI or UI based templates. So it's up to you how you want to or which type of templates you want to create. And then again, troubleshooting and monitoring can also be done using vManage. You don't even have to ever log in onto managed router locally. if managed router is having control connection with vmanage. Let's say you needed to have the CLI access of the managed router. You don't have to go to managed router directly using SSH by leveraging putty or some other software like secure CRT or so. If you are on vmanage, you get this option to have the access of the device using CLI. You don't need any external application like putty or that secure CRT and so. You don't need that. So you would be doing everything like whether troubleshooting or monitoring, you can perform that from the vmanage. Even vmanage gives you flexibility to run your commands using UI, user interface, or GUI, right? So they have a set of commands, predefined set of commands that you can execute on your routers in real time using GUI. You don't really have to access your device using CLI, but that option is also available. So you get what you want basically, or what you need onto your Cisco vmanage. All the software upgrade can be performed from the vmanage. Like you can upgrade the OS image of managed routers. You can upgrade the OS image of vSmarts, vBond. In fact, on vmanage itself. So all control components, including your data plane devices, right, like managed routers, can be upgraded using vmanage or from vmanage. And yes, one of the most important feature that it has is the role-based access control. Role-based access control. Like you would have different teams in your production environment, right? One team is kind of layer 1.5, because layer 1 is being replaced nowadays by all of the organizations mostly, right? They are calling L1 team now, as a L1.5 teams. Like they have more visibility, or maybe, they can perform kind of troubleshooting at. Companies are calling it level 1.5 teams nowadays, which was earlier called as level 1, right? And then you would have level 2 teams, then level 3 engineers, level 4 engineers. So based on their levels, like you would have different teams for different levels, and then you would require different level of access for those teams. And that can be done using this RBAC feature, role-based access control. So if you, let's say you have got a team whom you want to provide only read-only access, so you can do that. You can create a group, right, in which you can provide read-only access. Or maybe you wanted to provide read-write access for certain features, like you want your admins to shut down the interface, or to unshut the interface, or maybe to change the IP address. So that level of access you can provide to that specific team. Then you have got like maybe level 4 team whom you want to provide the full access administrative rights. So you can also do that. So like this is the meaning of role-based access control. Then we have also got those programmatic interfaces supported by the vmanage, like netconf and restconf. So REST APIs are supported by vmanage, yes, which you could leverage to perform integration between third-party applications with your vmanage. That can be leveraged over there. And apart from that, you were using VeloCloud, and then you want to deploy the virtual VeloCloud router on top of ENCS. So that is also supported, right? Even the virtual firewalls like virtual ASA, you can install it on top of ENCS. And if you don't want to use virtual ASA, then you can also use virtual SRX, the Juniper virtual firewall that you can install on top of that ENCS box. So I believe, like in my opinion, I believe this is something that Cisco has recently renamed. Earlier it was ENCS, or maybe it is quite similar to ENCS. I'll go through it. Thanks for sharing it with me. I'll go through it, and then I would try to grab as much as information I can get for you.
Thank you so much.
Okay, then programmatic interfaces, this is what I was talking about. So yes, it supports REST API and of course the netconf, right? So I have already given you an example of the use case for the REST APIs, but netconf, remember that by default, all these control components, including your managed routers or data plane devices, they all are going to talk to each other in maximum cases using netconf. Like for example, if vmanage is pushing something on managed router, is pushing some configuration or pushing something, or any command, vmanage is pushing a command onto managed router, or maybe vmanage is pulling something from managed router. So either vmanage is pushing onto any other component or pulling something from the other component. It will be using netconf for that, not SNMP. SNMP is outdated nowadays. Netconf is an advanced version of SNMP. Now remember, netconf uses SSH. Netconf uses what? SSH. So it is a secure protocol, completely secure protocol. So nowadays vManage is by default configured with the netconf, and if vManage needs to pull or push any information from other components, it will be using netconf for that purpose. Okay, now you might have a question that what about the other NMSs that we have in our network, and those are still working on SNMP. So can we deploy the SNMP? Can we configure the SNMP community strings on the managed routers in case if I want my managed routers to communicate with the external NMS? So yes, that is also possible. So you can still configure SNMP on your managed routers, right? You can still configure that so that your managed routers can also talk to that external NMS, right? Because vManage itself is also working as an NMS, right? But in case if you have got external NMS, maybe you were using some existing NMS and you still want to integrate that with your managed routers, you can do that. So SNMP is still is there, right? If you want to configure some SNMP community strings on your managed routers, still it can be done. You can configure it, right? But then by default, vManage is going to use what? Netconf. Like you cannot change it to SNMP. Like you cannot force your vManage to use SNMP to push or pull anything onto other components. You cannot do that. By default, vManage will be using Netconf for that purpose.
So it's suppose even vManage supports the SNMP, right? So it's by
Not
via
not
third.
vManage, not vManage. I'm talking about the managed routers. On managed routers, you can configure the SNMP community strings so that your managed routers can talk to your external NMSs.
Okay, how do we integrate on under vManage?
That's something that you can get to know when we are performing labs, isn't it?
Okay, got it.
So orchestration plane, which is also known as Cisco vBond, right? So this is orchestrator. I would also call it mediator. I would also call it mediator. You know why? I would call it first point of authentication. I would call it what? First point of authentication. Why do we call it first point of authentication? Because whenever you power on any component, whether it is a vManage or vSmart or a managed router, the first target for the device would be to communicate with vBond or to establish a connection with vBond. Talk about any component, whether it is vManage. Let's say you powered on vManage, so first it will go to vBond. You powered on vSmart, first it will go to vBond. If you powered on the managed router, first it will go to vBond. So vBond is going to work as a first point of authentication. Now, ideally, what happens is that when when you are doing power on for a managed router, right? So let's say your managed router has boot up now. So first it will go to vBond. It will get or it will try to authenticate with the vBond, with the orchestrator. If that authentication went good, if that authentication was completed successfully, then what vBond does? vBond will share the controller list. vBond will share what? Controller list with the managed router, so that then managed router can talk to vManage and vSmart. So what happens is that on managed router, you don't really have to configure the vManage IP address or vSmart IP addresses explicitly. No, you just have to configure the vBond IP address on your managed router so that your manage can at least talk to vBond. And that's the reason that vBond must have a static public IP address in case if you want your different components to talk to vBond over the internet. So if you have got internet as a transport and you want your managed routers to talk to vBond over the internet connection, then your vBond must have a static public IP address. And it must not sit behind a NAT device, especially PAT device. If it is sitting behind a NAT device, then make sure that you are configuring a static NAT. Because a static NAT is like kind of full NAT and it's like bidirectional. So if you hit that public IP address, then it will get automatically translated into the vBond's actual private IP address. So if you are if you are implementing or you are placing your vBond behind a NAT device, then make sure that you are doing only static NAT or one-on-one NAT. So that's mandatory for your vBond. So first thing is first that it must be configured with a public IP address so that it is reachable from all components over the internet. So managed routers must be configured with the vBond IP address. Although there is a concept of GTP, zero touch provisioning, where even we would not be required to configure a vBond IP address on a managed router. Managed routers would identify the vBond IP address automatically or dynamically. That can also be done, but that's a different story altogether. Okay. So as I said, it orchestrates the control and management plane connection. So I said that, okay, it works as a mediator, right? How? Because everybody is going to vBond, and then vBond is sharing all the information, necessary information, so that your WAN edge router can establish a management plane connection with the management plane, and then control connection or control plane connection with the control plane. Because if vBond is not there, let's say, so how come your WAN edge router would establish management plane connection or the control plane connection? So it is mandatory for us to allocate that public IP address on the vBond. Now remember that vBond also supports the NAT-T feature, NAT traversal feature, and that's mandatory for vBond to support that feature. There is a statement that I made, right? If you remember that, I made one statement that even your branch routers can sit behind a broadband connection. Behind it. Let's say you have a SOHO, small office, home office, right? So at your home, you got a broadband connection, and behind that, you have installed your WAN edge router just to have your corporate access. You don't want to configure, or you don't want to connect through the Cisco AnyConnect or remote access type of thing. Like you are a CEO, right? Or maybe director of the company, right? So you don't want that you should always connect to that VPN and so company decided to implement SOHO. So they would go and they would install one WAN edge router at the home itself, and then they would perform routing and so everything, right? So basically your WAN edge router can sit behind a NAT device, isn't? Which is doing PAT basically, which is doing PAT. So then how come that router can talk to another site who is also sitting behind the PAT? I mean, it's like my laptop. I'm in my office, you are sitting at your home, you are having, like, we both have access to the internet, but can I access the resource that is available on your laptop directly? Of course, no. Why? Because I don't know your public IP address. In fact, if you must be having that public IP address, but that is not a fixed public IP address that can change at any point of time. So then how come those WAN edge routers would establish the IPsec tunnel with each other, having the private IP address? Like obviously WAN edge would have the private IP, right? But then that private IP would get translated by the modem, or maybe, home router, or maybe, your NAT router, correct? So then how come those WAN edge routers would establish the IPsec tunnel over the internet? Since they are having the private IPs, they should not be allowed to send data over the internet, correct? So for today, I think this is it, right? This is enough. We'll continue tomorrow, isn't it?